All right, good morning, everyone. I think we're close enough to 10:30 to start, aren't we? If we get a few stragglers in, so be it. Welcome, everybody, here to, I'm going to get my acronyms right now, BCRRE. I always do it too many students, not enough R's, here at the University of Birmingham. And absolute pleasure to see so many of you here. Thank you for coming. I think, you know, the coffee that we've had so far has illustrated to me all the questions that there already are about hydrogen, because between you, you've already told me it's a massive opportunity, it'll never happen, it's food, it's too dangerous, don't forget the Hindenburg, it's amazing, it'll be everywhere, it's the best thing since sliced bread, etc. So I think, you know, you've framed it already for me perfectly, but this is a market that I think has got huge potential for rail freight. When we talk to government, they think it's got huge potential for the UK economy. They aren't necessarily thinking about rail's role in that. We need to help them do that. But it is undoubtedly a market that's got some challenges in total, some challenges on rail specifically. And if we aren't starting the conversation about them now, we'll be too late by the time that people work out that it's a really good idea and we should use trains. So I'm really delighted that you've all given it your time and commitment today. Many of you have been to RFG events before, like to run them informally. I think this is the kind of meeting where we really need your input, thoughts and ideas. So we've got plenty of time today for questions. We've got plenty of time in the panel session later for more questions. Please do give us your input. I think it's the beginning of a conversation, and no doubt many of you will get takeaways today from other people who are here, or indeed we can, you know, reconvene as, when and how we want to on the back of this. A few bits of housekeeping. In a minute I'm going to ask Stuart to do the official venue housekeeping, but just from me, we have a couple of photos taken already. They'll go on LinkedIn. If you don't want to be on LinkedIn, please shout now, we'll retake them without you. The toilets you'll have found just out there, they are unisex, so and there's only 3 of them, so when we get to coffee break, if you're at a certain age you might want to run. We will, you can get a copy of the slides afterwards if you just ask Yvonne. She'll get those out to you, so you don't need to take copious notes, and Jenny is recording it as well, so I'm sure there'll be some magical wizardry by which you can get a copy of the recording, but I have no idea what that is, but we are doing that. We've structured the agenda today really to start by talking about the big opportunity for hydrogen in general, and then focusing a bit more on where we might be with rail, talk about some of the barriers, and then at the end of the day, a panel where we're going to try and pull all that together, maybe think about what we need to do, some next steps, and how we might go forward on this. And it's a huge thank you to all the people who've agreed to speak today. Sadly, we've lost Sam from Eversholt, who was going to speak before lunch. He's unwell with a nasty chest infection and had to pull out yesterday. So apologies for that, but the agenda you've got in front of you, we've just moved it up to fill the space. There will be lunch, and if you need more coffee or water, please feel free just to step out and go and get some. And I think there's a Wi-Fi code for those who want it. But without further ado then, let me hand over first to Stuart, Hillmansen from BCRRE, who's going to give us a little bit of an introduction about where we are, what they're doing in this fabulous facility, and also the work they've been doing with hydrogen in the rail industry, which has been more about putting it at the front of the train than the back of the train, but undoubtedly will have some hooks and helpful things that we've learned along the way that will help us in that quest to have it behind the train as well. Thank you very much. You give me the magic. Here.
Right, can you hear me okay at the back? Yeah, excellent. So yeah, I'd just like to thank you, Maggie, for the introduction, and I'd like to extend my warm welcome to the University of Birmingham. We've got acronyms galore. So we're in the School of Engineering, the part of you're sitting in the Ukraine building, and we're also the Birmingham, or the University of Birmingham Centre for Railway Research and Education. So what we do for a living is both research and education, and I'm going to tell you a little bit about it. Before I start, just some brief housekeeping. We're not expecting any fire alarms today. If we do hear one, then it will be a real fire alarm or a drill, which you don't tell us about, actually. And we're to gather by the Faraday statue, which is just by the station. So people with orange lanyards will be guiding you and here to help you as well. If you need any other assistance, like first aid or something like that, then Jenny or anyone with a lanyard can generally help you out. And we already said there's toilets outside. I'm going to spend 15-20 minutes just introducing something about where we are, the University Centre, and I've got some few anecdotes about hydrogen as well to tell you. Yep. Oh, it does. Excellent. So we are the University of Birmingham Centre for Railway Research and Education, and this is a picture of a lot of us. So we never get everyone together in the same place at the same time, normally because somebody's in Brazil or China or somewhere like that. So we've got a big group of people here doing all aspects of railway research and education. And that was a photograph I think taken last year of when we had a lot of people here. We have a lot of working space, so 3,000 square metres of working space and laboratory and equipment. A house in this building, and we're deeply integrated into the School of Engineering. So the building that you see behind you is the School of Engineering, and we've got a secret door that allows us to go between the two. So we are there, and this is what we do: research, development, innovation, and education. So I think we're unique in our offering in terms of covering the whole piece. The education aspect is really important for us, and we use this room to teach groups of students. They're all usually from the rail industry, and they come and do our courses. They learn a lot about rail industry, but then hopefully in the future, if they've got research problems, they come back to us to do the research. So it's a virtuous circle. We're very keen on innovation and getting our ideas and concepts out into industry and doing stuff in the real world as well. We don't just theorise about railway research. So that's us. And we do it worldwide. As I said, we've got contacts all over the place. Railways are facing the same challenges across the world, pretty much. You know, capacity, reliability, safety, decarbonisation, and so on. So we can do the same, tackle the same problems in different parts of the world, which is good because it keeps money flowing, and then we keep having producing impact in different parts of the world. So we're active in all those places you can see there. If you were to put us on a pie chart, this is what we would look like. So obviously rail is a core focus, looking around the outside. And that feeds into mobility, so working with colleagues across the School of Engineering and broader, there's a lot of interest in other parts of the university and the general concept of mobility. Obviously education, innovation, collaboration with industry is important, international reach as well, and research. And then you might not be able to see the research areas in there, but we cover everything with strong engineering focus, looking at data science, sensors, automation, power electronics, propulsion systems, AC, DC electrification, hydrogen, but also things like aerodynamics and climate change and so on. And look, that's what I did in lockdown with Helen. So I think we were both, so Helen Simpson is going to be speaking later, so we were both on that, I think, when that photograph was taken. So during lockdown, I only went on one train, and it was that one. So I think we did something like 75 miles or something in testing on the main line. So we worked with Portsbrook and a whole host of supply industry to get to re-engineer class 319 into the first hydrogen train running on the mainline network, and that was a successful project. We, as I mentioned, our railway MSc project has been running for 30 years, and it has very much an international cohort. There are a big number of UK students, but it's international. We have students from all over the world, and I think we've probably touched it'd be nice to put a little dot on every railway that we've got our fingerprints on, and there would be a huge number of railways that have been influenced by the education they've got here. And this was Professor Clive Roberts with both of these, all of these people have left the university now. That's a good thing or not. There's former Vice Chancellor and Chancellor Professor Roberts were awarded the Queen's Anniversary Prize for Further Education and Higher Education in 2017. So we got that. One of the things that we're quite good at the university is spinning out our ideas into industry. We've got a number of spin out companies as well that are doing work. So Monorail does work on sort of instrumentation and basically inertial sensors that you can put on bogies and axle boxes that can give us information about track quality, which is very important. Because we need good track quality. Vanguard, we've got people from Vanguard here today who spin out from our work on hydrogen. Repoint's one of our latest spin outs, looking at the next generation of track switches, and Anyrail, another spin out looking at energy savings. We've done an awful lot of work on light rail. We working with Edinburgh Tram, Nottingham Trams, and also now with Manchester Metrolink. So shortly we'll have done all the trams and saved quite a good amount of energy, which also turns into pounds, which is good. There's a huge amount of companies we collaborated with. I always worry about this because we probably miss people out. So there's probably more people than this on here on this. So lots of other universities and companies that we've got agreements with and exchange students, do research projects and so on. And there's another one. So there's hundreds of people. So please feel free to engage with us and work with us, and we can get you local work as well. So the education programs cover masters, but also an important aspect is our PhD programs, and we also can run short courses. So there are a number of short courses that we can develop for specialists, and we can do these for junior people or more advanced people in the careers. And if you know how to use LinkedIn and stuff like that, we can take this. I think these are going to be circulated, aren't they, the slides, so we can get that very easily. Right, so that's an introduction to the group. I'm going to tell you a little bit about hydrogen, and Maggie's already covered this. I think you covered this in the coffee break. So, you know, hydrogen isn't energy. It's an energy. Everyone gets upset about hydrogen. Once I showed this, and someone got really upset. I called it a vector. But the idea is you make hydrogen from something, and it can be used to transport energy from one place to another. So it's got a magnitude and a direction mathematically. If you think. One of the issues producing hydrogen requires more energy than is released when it is used. So that's one of the sort of Achilles heels, but not necessarily a problem, because we're quite often telling wind turbines we're paying them to turn themselves off. Right? So you could just say, "Oh, keep yourself running. I'll just make some free hydrogen." So you can potentially make hydrogen for very, very low cost if you get the economics right. Shouldn't we just electrify everything? Yes, it would be nice if we had an electric railway everywhere. However, we haven't, and it's not going to materialise anytime soon. The goal is decarbonisation. So, like, electrifying is good because we're riding on the coattails of the grid. Then, however, you know, hydrogen is much more profitable and achieve realistic on the less dense routes. Obviously, it always crops up. Isn't hydrogen dangerous? And the answer is yes, but we've been using it for a long time, and you know, the engineering behind hydrogen is kind of first rate actually. So we don't really have a problem. I've got some slides to show you this in a minute. I started thinking about this in early 2000. Was at Imperial College, and I wrote a paper on application of fuel cell technology to rail transport, and looked at how it can be used as a fuel for railways. So as Maggie said, today is more about how we move the stuff around using freight, but our focus up until this has been using it as a fuel to power trains. There's very different types of traction, obviously, on the mainline network, and obviously freight. I haven't got a freight picture here, but it shows you, a DMU style service and a high speed service. There's no way you can run high speed services using hydrogen, that's for sure, right? They're too powerful and they go a long way and they use too much energy. So you end up filling the whole train with hydrogen and have no room for passengers to run at the energy levels they need. However, the lighter trains, lower power duty cycles are suitable for hydrogen. I made this graph up a while ago saying where we could look at hydrogen. And with the scales, this is terrible if you're a physicist. I was a physicist. There's no axes on the prop or anything. But the x-axis sort of represents intensity of service, and where you've got very intense routes, the obvious choice, you compete between diesel and electrification, and electrification should be cheaper for intense services. Then at the low intense services, there's a competition between diesel, battery and hydrogen, and then electrification will be too expensive. You wouldn't ever be able to justify it on economic terms. And then somewhere in the middle, hydrogen can definitely get you further than the battery train, and that's where we think that using hydrogen for propulsion makes sense. I wasn't the first to think about hydrogen. This was something I took out of the Railway Safety and Standards Board. They've archived loads of stuff, so you can find this on the Spark website. So this is from British Railways Board, the Research and Development Division. Looked at provisional study of hydrogen as a fuel for rail traction, and that was back in 1976 when they realised it could be used. This is a screenshot from some of the paper. It's talking about how the chemical industry is using hydrogen. So hydrogen is used as a process gas in chemical processes, and it says in the latter part of that paragraph, the ICA Birmingham plant, it was doing 50 tonnes a day, and it's compressed to 250 bar. And there's no major incident, and it has been going for 30, 40 years. So this was 50 years ago. It had already been used for 40 years at high pressure, and 50 tonnes a day at high pressure. Like I said, the engineering it's long established, and we can move this stuff around safely. And there's a great deal of understanding about how hydrogen should be used. In the industry. This is another interesting one from that paper, suggesting that we should do electrification, and back then the economics suggested it's £52,000 per single track kilometre of electrification. That was not a lost opportunity, wasn't it, really? So I don't know what we're looking at now, but £52,000 doesn't play a lot these days in the rail industry. My local station is having 3 lifts introduced into it, and it's apparently costs £7.5 million for 3 lifts to take you up. I was going to write to Network Rail and say, just give me the 7.5 million and I'll carry people up. The rest of them, so it costs a lot of money, stuff in rails, but back then there was obviously interest in full electrification back in 1976 as well. And this is another graph from that. So this has kind of gone away a little bit. There was a term called peak oil, and it's quite interesting, showing the various peaks of oil production, gas production, and so on. And unfortunately, we keep managing to find more oil and more gas, and so the peak keeps moving away. And we're nowhere near hitting any of these peaks. So, the oil production peak should have been just before 2000, according to this paper, but it's not. If you look at how much oil that we're using, it's continued to go up since back then. So we haven't hit peak oil production globally yet. I guess some sites are peaking. So the sort of things that you will hear when you talk about hydrogen, some people say it's the abundant element in universe, it's true. Hydrogen is fantastic energy density, that's why we're considering using it for fuel. I mean, hydrogen is the thing that gets rockets into space and so on. So it is when you can have it in liquid form, particularly, it's a fantastic energy carrier. And we can make hydrogen through a range of means. Oh yeah, including by us. So there's a hydrogen test you can do on your breath. So if there's a certain medical condition, I think it might be like lactose intolerance or something. If you're lactose intolerant, you have little bacteria in your gut which like belch out hydrogen. So you can detect. So we produce hydrogen as well. Not very much of it though. There's a volume problem with hydrogen because it is very light, like gas. 1 kilogram of it at standard temperature and pressure would take up about 10 cubic meters. So it's about 1/10 the density of air, and even in liquid form, it's about 1/10 the density of water or thereabouts. So even a liquid, it's a light liquid. So the volume, we have a volume issue, not a mass issue, a volume issue. And making it economically is a challenge here. And some people say if you're producing hydrogen in a green way, should you use it for transport? But this is maybe where the rail freight industry comes in, because you don't really care what your customers are using the hydrogen for. If it's going into making more effective use of steel or something on the steel process, then that's okay as well. So when we've looked into this, we've done some projects on hydrogen trains. That was me when I had more hair, and that was the Secretary of State for Transport like 3 or 4 ago. I can't remember how many ago it was. That's Chris Grayling, and we introduced the Hydrogen Hero train to him. And then that led on to the work that we've done with Portsmouth. I'm sure you know about this. And Helen's here as well. She's going to speak later about barriers to the introduction to hydrogen and so on. And what we did for that was strip out the motor car and put all the equipment inside the motor car to demonstrate that would work. So it's been evolved since then. That was a collaborative project. We did lots of work with all the supply chain to get the train up and working. And there's a picture of it running around. There's a rock train that we hired. Obviously, we didn't want to get stuck. We didn't get stuck on the main line, but if we had got stuck, you get a big Schedule 8 payment thing. So that was there just in case we needed it, which we didn't. But we ran to Evesham and back, and since then the second version of Hydroflex runs around the network a lot. It's code number 799001, I think. If you Google it, there's loads of YouTube clips of it running about the place without using Spanchgraph. We're not the only ones. So this is Canadian Pacific with a freight conversion to hydrogen. So that's operating now, as I understand it. And then this is probably the most famous hydrogen train, Correa Island from Alstom. I think I've got a world record for distance. I can't remember. It travelled 1,600 kilometres or something on one fill. So about 1,000 miles range and so on. Stadler have this train, the Flirt H2. That's now going to be operating in the California region, so it's running on the Redlands Railway in California and San Bernardino. And then obviously Siemens have got their own platform as well that will do hydrogen additionally. And then this is a concept, I think, from it might be Vittel or Evian or someone, one of the French water companies converting a locomotive to have a hydrogen tender behind it to produce power that feed into the locomotive. Yeah, anyway, so that's it for me. I can hand back to Maggie. So it's a bit of an introduction to hydrogen. Please, I hope you have a really good day, and feel free to ask questions. It comes up, I'm sure people will be happy to do that. Yes.
Could you just explain what, if people want to do the tour, what they might
Yeah,
see?
you did. Yeah, thanks a lot.
And I think you said it was about an hour, maybe.
Yeah, so you'll see your agendas at the end. There's an optional tour of our facility, so it'll take maybe about an hour-ish, depends on any questions you ask. So what we'd like to do is get an idea of the number of people that might want to go on that. So so if you can put your hands up, I'll do an estimate. So it's 2, 3, 4, 5, 6, 7, 8. So shall I say 10-ish?
Yeah.
So yeah, if more people want to go, that's not a problem. Maybe just let everyone know, and then we can arrange the right number of people to take around the laboratory facilities. Okay, right, thank you very much.
I just shout, I do the mic switch over, but. Yeah, it's great talk. I'm not doing it 'cause my daughter's student at Birmingham and I've got to go and spend money on her apparently. So, I bet you've got and Robin. Robin, are you sent the talk?
Yeah.
Yeah, brilliant. From RFG over here as well, so we go up to me. Right, okay, let's back to the agenda then. So Stuart's given us a bit of an overview about the work they were doing to make trains run on hydrogen, and we'll hear more about the learnings from that when Helen speaks just after lunch. But I think if we're going to be talking about can we move hydrogen on rail, the first place we've got to start is how much hydrogen is going to be made, who's making it, and where's it going before we can even begin to unpack that potential opportunity. So really delighted to welcome Andrew Winship, who's the Deputy Chair of the Hydrogen Energy Association. I'd like to say they're a bit like rail freight group for hydrogen, but I think they're a bit more impressive than that. But Andrew, thank you so much for coming.
Right.
I'll give you that.
Okay. Okay. Hopefully you can all hear me okay. Yeah. Okay, thank you. Thank you to the Rail Freight group for the opportunity to speak to you today. I'm Andrew Winship. I'm one of 2 deputy chairs of the Hydrogen Energy Association. So I must have drawn the short straw trying to speak to you, but hopefully there'll be an interesting discussion resulting from these presentations. But when I'm not wearing my Hydrogen Energy Association hat, I lead the hydrogen team for in EMEA for GHD, who are a global engineering consulting firm who are very active in the rail sector. So some of you may know who we are, but certainly that's probably from some of my other colleagues to speak about on another day. What I want to talk to you about is more about the market for hydrogen, principally in the UK. So moving on from what Stuart said, although there is some overlap later on, and also give you a flavour of what the future might look like. But before I do that, I'd like to say a little bit more about the Hydrogen Energy Association, the role that hydrogen is likely to play in the market, and as I say, give you a little bit more of a picture of what that market looks like today and in the future. So the Hydrogen Energy Association, it is, in my opinion, the leading UK hydrogen trade association. We've been around the longest of any others. We have over 110 member organisations that span the whole hydrogen supply chain. So that's kind of production of hydrogen through storage, through transport, distribution, and end-use application. So a lot of our members, logos are on the slide there. You might recognise many of them. We act as a focal point for not just national hydrogen, kind of activity and engagement, but also international. And we've got some very strong connections internationally as well. And we also convene a thing called the Hydrogen Coordination Forum, which is attempt to bring all of the related industry associations, the REA, other ones like the Northwest Hydrogen Alliance, Energy UK, so that we're all starting to speak with the same voice and kind of promoting and trying to accelerate the creation of this hydrogen economy. So what role will hydrogen play? Well, Stuart touched on some of this already. We have a decarbonisation agenda in the UK, and hydrogen, will have a role to play in that. It's not the silver bullet solution. There are lots of other things. Electrification obviously makes a lot of sense in a lot of cases, but there are some hard to abate sectors like steel, like aviation, shipping, even power generation in some cases that are difficult to electrify, and you need something else. And I think that's the role that hydrogen is going to take. Now, if I could tell you these numbers were accurate about what it's going to look like in the future, then I'd be a wealthy man. But these are government forecasts, out to 2050, where hydrogen could account for about 35% of the final energy demand. So the future looks rosy potentially for hydrogen. As I mentioned, it can be used in a whole range of industries, steel making, chemical production, and even fuel production. So, you know, the aviation sector and the marine sector are looking at sustainable aviation fuels. Hydrogen is a key feedstock to production of sustainable aviation fuels. Equally, the marine sector are looking at things like green ammonia, green methanol. Equally, hydrogen is a feedstock to producing those kind of fuels. Steel making as well, hydrogen has a key role to play. And as you see later on, in power generation too. Also, it produced in industrial heat as well. So there's a number of applications. There are a number of projects active in the UK at the moment where they're looking at switching natural gas to hydrogen for industrial heat. So in cement manufacture, in asphalt production, and even whiskey distilleries in Scotland. Hydrogen also has a role in power generation in terms of producing and delivering energy resilience. So as we put more and more renewables onto the system, obviously those renewables are intermittent. So we need something that, in order to kind of balance and manage that intermittency. And one of the good things that is often talked about is you could use hydrogen using excess, if you like, renewable power, produce that and store it. And it is a good long-term storage solution. Now, battery technology is equally advancing, but the thing about hydrogen is once you store it, you can store it for months, you can store it for years, potentially as compressed gas. So, and you can see from the slide that we know that it's common that renewables get curtailed. That costs money. That money ends up, electricity and power consumers ending up paying. And hydrogen potentially offers a solution to make savings in that space. The clean power, the NESO Clean Power Report for 2030 clearly identifies hydrogen as a detachable, low carbon technology, and also goes on to refer to needing somewhere between 4 and 6 gigawatts of long duration energy storage. So again, there'll be a role for hydrogen in this space too. Hydrogen will also deliver economic growth and jobs. So, there's a global demand for hydrogen technology that's expected to increase to about 700 billion by 2050. If we, as an economy, get a share of that, that's going to obviously have a great impact on the economy and for jobs. And there are a number of, major clusters emerging in the UK around Teesside and in the northwest, and Humberside and in Scotland. And those could be, the first start of that economic growth and those jobs. We also have a long history in oil and gas and expertise that could be transferred from that sector into hydrogen development. So what does the market look like today? Stuart already mentioned that we've been producing hydrogen for a while. The Birmingham plant actually came online in 1936, so for nearly 90 years we've been producing and supplying hydrogen in the UK. So hydrogen is not new. We currently produce about nearly 790,000 tonnes, or there is capacity to produce 790,000 tonnes a year of hydrogen. There's round about 570,000 tonnes a year of actual production in the UK. But the vast majority of that is produced from natural gas. So what we do is you take natural gas, split it over a catalyst, and you produce hydrogen and CO2. Clearly, we don't want to do that going forward. So there's only a small percentage of that hydrogen comes from electrolysis, which is splitting water with renewable electricity. So we need to do more of that. But in terms of potential, all of that hydrogen that's produced in the UK at the moment is supplied to customers in tube trailers on the road. There is no hydrogen pipelines, commercial pipeline supplies in the UK. There's no rail, although you guys might know better than me, that I'm aware of. So all of that is moved on the road. And if you say a tube trailer is about, you know, a ton's worth of capacity, that's nearly 600,000 vehicle movements every year. And it's not just the vehicle movements, but it's the emissions that are associated with those vehicle movements as well, that need to be kind of taken into account. So there's some significant potential there, and that's just with the existing customer base, merchant hydrogen at the moment. So it has a role to play currently. What's going to happen in the future? So this UK hydrogen project map has been kind of created and it's updated by the Hydrogen Energy Association to capture, you know, kind of where the main activity going on in the UK. So we have over 17 low carbon hydrogen production projects, post feed captured on here. The green circles are electrolytic green hydrogen. The blue ones naturally blue hydrogen, which is using natural gas with the CO2 captured. There's nuclear, so there's not just hydrogen production on here, there's also end use applications around kind of hydrogen for transport, hydrogen for commercial and industrial applications. So we're trying to capture everything in this, you know, and keep that update as an association. And there's a link on the slide there to the map. So and you can go in and interrogate it, you know, and there's information on each of the individual, you know, kind of dots that are on the map there. This is likely to grow. I don't know if many of you are aware that the UK government has a incentive scheme in place called the Hydrogen Production Business Model, and it's a contract for difference scheme which supports early stage green hydrogen production projects. Now, we've had one round of this hydrogen production business model. The industry is currently waiting on the short list of projects for accepting, and there was something like 87 applications put into that second allocation. So this might be the picture at the moment of projects we know about, but there's a whole load of others out there that are going to end up going on this map. So this is only going to grow out to the, you know, kind of hopefully to the numbers that they're going to forecasting from the earlier slide. So just in summary, hydrogen has a critical role to play in decarbonising our hard to abate sectors. So it is one of the things in our toolkit to achieve our kind of net zero targets. And demand for hydrogen is expected to grow over the coming years for various reasons: production of sustainable aviation fuels, decarbonising steel. But the majority of merchant hydrogen supplied at the moment in the UK is via road transport as compressed gas. So there must be the potential there for some other alternative transport options to consider. So I'll stop there. I don't know if we have time for questions. I'm happy to come and take some questions at this time.
Yeah, sure. We've got time on the agenda in lots of places, but yeah, particular questions people want to ask Andrew now, and then we can do that now, and then later on we can have a more general discussion. Ralph.
Cut to chase. How are you going to move all this stuff around? Because I'm highly skeptical. It has to be pressurised or chilled.
Yeah.
Containment is really, really heavy. We talk about 1 tonne on road vehicles, that assumes it's 20 tonnes worth of containment.
Yeah.
Or 19 tonnes worth of containment.
Yeah.
Rail can't manage the massive, very heavy tanks, don't work very well. What kind of pressures are you working at? 250 bar. How are you going to put that around like a? There's lots of mature organisations there.
Yeah.
I've tried really hard to understand the logistics of this. I can't see anybody with an answer. How are you going to do it?
Yeah, I mean, well, currently it's being moved as compressed gas, and I absolutely agree with you that really what we're
How are you going to move it?
well, pipelines. The most efficient way to move any kind of gas, as we know in the UK, we've got a very extensive natural gas, you know, kind of distribution and transmission network, and those companies are looking at blending hydrogen into those, you know, kind of networks. They're also looking at 100% hydrogen networks. So, you know, that's likely to be a solution in the future when the volume kind of increases. Road transport seems to be the most common solution at the moment. I agree, kind of when you go beyond the UK and you look at import and export and international and kind of transport hydrogen, that's when you kind of start to talk about turning it into ammonia, turning it into other things that are slightly easier to handle.
So you're gonna vector the vector.
Yeah. Yeah, no, I agree. It's not, it's not, it has its challenges. I mean, my background, before I joined the HEA is in industrial gases. I work for BAC. And there's a reason why there isn't an international trade in hydrogen, because it's bloody hard to move it around. That's why, most industrial gas hydrogen production happens in individual countries. But there are some interesting solutions being considered, things like methanol, things like ammonia, which you can use directly in things. So, you can use methanol as an intermediate product to produce sustainable aviation fuel. So you're going to produce that in somewhere where there's cheap renewables, put that on a ship and sell it to the UK, then you don't necessarily have to turn that back into hydrogen. Use it for something else. So all of these things are in the mix at the moment. So there's no easy solution, absolutely. But there are a number of options that we kind of explore.
I mean, look, where I am, I get it's a really difficult market, and 3 years ago, I think everybody was going to be using hydrogen. We were literally going to be using hydrogen 3 years ago, weren't we? It was the answer to everything. And what Andrew explained now is it's coming down to some big industrial users, most likely, some bits on the margin. So the market's evolving, and I think the transport has to evolve with it, and that's why I think inserting rail into the options at this stage is so important. It will evolve. It's not perfect. We don't have the answers, but if we're not in at the optioneering stage, we won't be in at the end.
That's true enough. If it's transported the way it is today, looking to the future, it might well be kind of via pipelines. I don't have the answer to that, but that's probably the most efficient. That's definitely the most efficient way to move gas around. There's a period in the middle there, that lots of options are available.
Brilliant.
And also, if anybody's interested, I'm happy to talk about membership in the HEA at the break. Anyway, thank you very much.
No, thank you. Brilliant. And we've got a bit more time for questions later on. So if you've got something burning, we can come back to that in a bit. Right. There we go. Right. So next up, so it's probably timely to have a little bit of a chat about what the rail industry has been doing to date, because it isn't nothing on this question. And Greg, who's the Freight Business Development Manager at Network Rail's Freight team, is going to talk to us a little bit about the work that he's been leading on this. Greg's also been working on carbon capture, and no doubt some other things as well, which might come back to us a different forum another time. But today it's hydrogen, Greg, so thank you. And over to you.
That's okay. I'll just press up to go.
Yes, sideways.
Okay, cool. Hello everyone. So I see lots of familiar faces in the audience, but lots of new ones as well. So for those that don't know me, my name is Gregory March, as Maggie says. My job within the Network Rail Freight team is Freight Business Development Manager. What does that mean? Well, pretty much everything it says on the tin. So my job is to do everything and anything to try and get more freight on rail, but that's developing the freight estate, working with existing customers to do more, ultimately working with new to rail customers as well. Part of my job also involves things around market intelligence and looking at what future markets might be, which is how I got involved in this topic. So, title's slightly obscure, but the point of this slide was twofold. One, it was to, I suppose, reaffirm the point that rail freight already plays a critical role in the energy industry, whether it's moving biomass to trucks, aviation fuel, things like that. But it's also to say that rail freight has a history and a successful history of moving dangerous goods, because ultimately the movement of hydrogen by rail would be classed as a dangerous good as well. In terms of the picture, obviously you've got Drax up in the top left corner. The one next to it in the top right is gas condensate that runs from North Walsham to Harwich. And then on the bottom left hand corner, you've got aviation fuel that runs from the Isle of Grain to Colbrooks via Heathrow. And then in the bottom right hand corner, you can see obviously that's a road trailer, but that's a typical example of liquefied natural gas that's typically moved by rail, often up to Scotland as part of the Tesco train. So again, as part of a mixed concept in that sense. So I suppose the point behind showing this is one of the most common questions I get asked, when getting new inquiries about hydrogen is, can you move it by rail? And the answer is, yes, you can. Won't dwell on this too much because Andrew's done an excellent summary, but I suppose just to canter through quickly. So at the moment, hydrogen represents a relatively small element of the market, but it's viewed as an alternative transport fuel and an alternative to fossil fuels in heavy manufacturing environments. The UK government, or previous UK government, I should say, produced a hydrogen strategy back in 2021, which had a roadmap of how they were going to get 10 gigawatts of production capacity by 2030. To give some context, I think it's varied slightly over the years, but the peak kind of requirement is about 60 gigawatts. Hydrogen strategy estimates that to meet the 2050 net zero targets, hydrogen will need to make up between 20 and 35% of final energy demand. The current government updated, I suppose, somewhat in the budget back in October by agreeing to fund a number of hydrogen projects, which are done through either the hydrogen allocation round, but also the net zero hydrogen fund, which aims to support capital investment. It's important to note hydrogen production can take the form of both liquefied gaseous or via a carrier, as Andrew mentioned, such as ammonia, methanol. And it's also fair to say that the potential growth of hydrogen derivatives markets, such as fertiliser and sustainable aviation fuel as well. The map on the right is a version of the map that Andrew showed you, and again, it's a really interesting link to look at, and it kind of highlights where the different projects are. And the top rainbow again, slightly obscure, but again, that's just to say there are different types of hydrogen in terms of the hydrogen rainbow, and it's primarily driven around how they're actually produced. So, as Andrew said, at the moment, the majority of hydrogen we produce is grey. So again, we're not capturing the carbon, so it's not particularly green. If you do capture the carbon, it's blue, and if you do it in a sustainable manner, it's green. Anything else is either not so great in terms of black and brown, or done by a different method. So, notwithstanding Ralph's point that he made previously, in terms of numbers, I suppose the point again of showing this is really to highlight two of the different options and how you might really move hydrogen by rail. So broadly, there's two solutions. There's bulk and there's an intermodal solution. Bulk is where typically we have a producer who had a direct connection to the rail network or was having an ability to connect to a nearby one. And ultimately, the intermodal solution is where potentially you'd be looking at using a bulk container, so similar to the one that we saw previously. For moving liquefied natural gas. And again, the idea there is we take it to an established railhead for onward movement and then subsequent movement by road as well. In the bulk solution, you'd be using a traditional tanker wagon to take it directly. And again, the numbers on the right, so they're very, very crude, so I'll caveat before anyone says anything about them. But really, it's to kind of highlight what might be potential in terms of a typical consist. There needs to be further work in how you do conversions in terms of taking it from gas to liquid and what it means and all the rest of it. The megawatt hours energy capability was based on a very, very crude analogy. I think it's for every ton of hydrogen you produce 33 megawatts capability, something along that line. And again, it's an idea there of the type of way that you might use. So, progress today. So on the left, you'll see the market digest. So I mentioned at the very start that one of my jobs is to ultimately be market intelligence, speak with the industry, understand where it's at. And just before Christmas, we published one that I've written on the new energies market. So hydrogen, carbon capture, utilisation and storage, and also sustainable aviation fuel. And the purpose of the document was ultimately to speak with the industry, understand the potential for rail, understand what some of the potential barriers and challenges were, and ultimately set out a number of actions that Network Rail could do in conjunction with the industry to try and progress the discussion. So a number of you in the room will have contributed to it, so thank you very much. If you'd like to see a copy, it is published on the GBRTC website. Well, this still is a GBRTC website before transfer it back over to Network Rail. But if anyone would like to see a copy, I will get Yvonne to share a link. But equally, let me know and I'll share it 2. In terms of the image at the top, so I think BTG are in the room. Thank you. So I mean, this was ultimately following discussion. This is typically in terms of their CO2 prospects. Well, I know that they've also been working on hydrogen and other things, and particularly in terms of taking European designs and scaling them down in the UK market as well. But again, I suppose the purpose of showing this is that there are people out there, and you know, in addition to the other wagon manufacturers I know, are also looking at it as well, and we'll come on to why that's important and how it's a challenge as well in the next slide. In terms of the document at the bottom in maroon, so again, that's some of the work we've done with our dangerous goods team and Milton Keynes. Again, just kind of firming up some of the requirements around moving hydrogen. As I said at the start, it is dangerous good. It does have a UN number for both its gaseous form and liquid form as well. So again, there are a whole load of protocols that are established around it. What we'd like to do is kind of further those discussions internally before we kind of take it out to the market, and ultimately the point is to try and reassure people that again it is perfectly safe to do so. Standard requirements around dangerous goods apply, and actually in some ways there's a demystifying element to it to kind of dispel the idea that you can't do it. But ultimately as well, certainly from the discussions we've had internally with say root colleagues and all the rest of it, there's lots of interest in it, but there's also people who are quite naturally curious about what it means and what additional kind of briefings might have to be put in place as well. So as the market develops and it becomes a bit more firm about what we're actually going to be doing, I think that will develop as well. And without wishing to steal Helen's thunder, there's a lovely picture of a flat so I've lucky enough to be invited to an event with the Vanguard team at the Severn Valley Railway a couple of weeks ago. And it's a demonstration of the O8. And which is a hydrogen fuel battery electric, is that correct? There we go. Brilliant, and I suppose again, as much as here we're talking about an element of kind of hydrogen traction and also how we move it. I think one of the really interesting bits about development of kind of shunters and green shunters in this way is even if you were to electrify 100% of network rail's infrastructure, there is still a challenge in that most energies are kind of facilities, whether that's bulk or for intermodal traffic, aren't suitable for wires. And so you need some kind of green solution. We've seen development of kind of battery electrics and all sorts of other things, but I think this actually offers on a smaller scale and perhaps something that's a bit more manageable in a short term, an opportunity to actually decarbonise terminals in that sense as well. So really positive that again, it's not just theoretical, there's something out there that's physically running today. That you can see, and again, we'll look forward to seeing how that develops as well. So last slide. So again, one of the things we tried to do as part of the commodity digest was to think where might we be in 2035, so 10 years time, which feels a long time away, but actually it's not that far at all. And the column on the left gives you an idea of kind of what we've done. That's a very conservative estimate. Ultimately, it might be a fraction of that. Equally, that might be a drop in the ocean in terms of what it might be. But again, we thought it was quite important to put some kind of thought behind where it might be for both hydrogen, carbon capture and sustainable aviation fuel. In terms of some of the challenges that the commodity digest found, and again, you'll hear a lot about these. Market uncertainty is clearly a big one. You get the sense that all three kind of new energies that there's an element of chicken and egg, and that something's waiting for something in order for it to happen, and rails in the middle almost waiting to see what the outcome is. The scalability element is there as well. If the market suddenly takes off and it does become a scalable thing, we need to be careful we're not trying to play too much to catch it with that, because otherwise we potentially miss the opportunity. Equally, there's a challenge that if we can't provide some kind of assurance for any of the new energies commodities that rail can actually do, it's not just somebody up here saying it, the risk is that they'll develop something else or it won't happen at all. Investment is clearly key, not just in terms of the kind of the non-rail elements, in terms of the hydrogen production facilities and everything that goes with that. But clearly, if you're ordering new wagons, bulk containers, locomotives, people, investing in terminals, there is a price to take to that as well. And also, if you're looking to connect a new facility, clearly there's a sizable price tag to that as well. Development timescales is absolutely key, and Maggie's already touched on this, but I think it's an absolutely critical point. I think sometimes with this, it's really easy to think, well, it's something that might not happen until the end of this decade or going into the 2030s and beyond. The risk is we don't talk about it now, and we don't consider it now, which is why we're all in this room together. By the time it does become a real opportunity, it'll be too late, and that we'll have missed the boat on it. And so there's a real need to actually talk about it now. Yes, we might not have all the answers now, but actually there are lots of things we can do to understand what it might look like and what we might need to do. Around capacity, connectivity and capability all comes into it as well. And again, that's understanding how, if all this traffic was to come off, ultimately, you know, how do we do it? What does it look like? And where, you know, and what investment might we need to make to facilitate it as well? And just finally, so the commodity digest came up with a number of actions, and again, I'll answer these quickly before we do any questions. So one of the key bits, and this is an ever-evolving thing, is to actually chart and map where the opportunities are in relation to rail connectivity. We've seen the maps of all the projects, and obviously some will drop off, some will become on, but there's an action to ultimately understand where they are, and from that understanding what, in terms of what's their likely movement. Is it for an intermodal solution? Is it for a bulk solution? If it's an intermodal solution, where's the nearest railhead, and so forth and so forth. The idea being that we start to build a picture that's more than just saying, well, we know there's opportunities in the north east or the east or the south or wherever it might be, because some of these following actions we can't do if we haven't taken that first step. There's a need, as I mentioned, to build on internal network around and wider industry understanding about demystifying dangerous goods regulations and general safety related topics. If nothing else, and I hope it's not the case, but I sometimes fear that people assume that you can't do it by rail, so don't bother having the conversation, and I'd very much like to move beyond that. I'm not saying there aren't challenges, by the way, but actually, you know, we can overcome them through discussion. There's also a need to explore the potential use of the freight estate to support new energies markets. That could be everything from basic kind of, you know, transshipment and onward movement through to storage options as well. Increasingly, as the freight estate develops and as the rail freight market develops, there's a need to do that anyway. But we also, you know, in line with thinking about we can't afford to miss the opportunity. If we know we've got the freight estate near to where some of this stuff is going to be produced, we should keep that in mind as we develop it as well. Likewise, we need further work to establish the key rail access and the path requirements and what quantum of paths we're likely to need. And this is absolutely crucial in terms of the development timescale argument. If none of us did anything after this meeting and we waited until 2030 and then decided to do it, I suspect we'd find a challenge to actually find the right quantum of paths to be able to have. And ultimately, when people are going to make the investment in hydrogen or carbon capture, or whatever it might be, there will come a point where they have to have some kind of assurance that if they do commit to it and if they do choose rail as the key logistical method of moving it, that it actually is possible, because it's going to be a hell of an own goal if it's not, and we will be saying that it can be done. So there's work to be done on that, and in terms of getting strategic paths in the timetable on key axes to make sure that their growth can be accommodated. Another one, New Energies Conference. Well, we're here, which is brilliant, and this started, you know, it's something that Maggie and I have discussed for quite a while, but it feels quite timely that we're doing this, and hopefully we'll have future ones on carbon capture and sustainable aviation fuel as well. And actually, you know, there won't just be one-off events, there'll be things that as the markets develop, we can revisit them as well. And I hope, you know, more than anything, people make connections today, and while we speak and we say hello, you know, rail don't pay for business cards, unfortunately, but I do have LinkedIn, so that's something at least. Continued engagement with both energy producers and emitters in terms of carbon capture and potential storage entities to help develop non-pipeline transport railhead proposals. Obviously, that started with the commodity digest, but it's an ongoing process. As the market develops, we need to understand how it's developing, what the latest emerging trends are, because again, the risk is, if I didn't do anything else after releasing that commodity digest and it's sat on my shelf, the risk is it become outdated pretty quickly. And so it's already going to be revisited this year for a refresh as well. And I look forward to engaging with a wide group of people as part of that. There's also an element of continued engagement with heavy industry established rail users, of which there's a couple in here, the room today, who are seeking to decarbonise about what kind of the new energies world, particularly hydrogen, might mean, how it can be used in terms of their existing logistics solution, and again, what that might mean for the rail network. And also, and this is absolutely key, and again, Maggie touched on this, is continued communication with the government, and not just from the DFT, but it's also the likes of DESNES as well. We've made significant strides from where we started in that. as Maggie said, I think particularly with there's an element of when we first spoke to them, it was a bit like, well, we haven't really considered rail at all, and that has developed, and certainly we're seeing if you look at carbon capture and non-pipeline transportation, they've come on leaps and bounds in terms of understanding that rail actually is a viable and a real thing they should consider. So that's kind of absolutely key. I think the other point, and we keep making this to government, is there's an opportunity with all of this to almost kind of meet two different objectives. They've got the rail freight growth target of 75% by 2050. The new energies market, if it takes off in any of the formats, could represent a significant opportunity to actually achieve a chunk of that. So actually, for a bit of targeted kind of policy and working closely together, you'll believe sometimes that the departments don't actually necessarily speak to each other. But they're getting better at it. There's a real opportunity there to kind of meet both objectives. So that was me. Hopefully that's been interesting. Appreciate it's quite high level. But as I said, absolutely happy to engage with everyone and anyone around this. You know, it's something that I think really is a genuine opportunity, notwithstanding there are challenges to overcome. And for me personally, so I've literally just turned 39, I appreciate I'm much older. For me, this is something that, you know, potentially as it develops over the next 20, 30 years, I'll hopefully still be working in rail freight to actually see this come to fruition. And it'd be great to think back to how we stood in rooms like this and had the conversation, and it acted as a catalyst for rail. So, yeah, there we go.
Great. Thank you very much, Greg. Thank you. Quick question for Greg, and then we'll come back to some more at the end.
Yeah, so people and skills which can cancel their development. So probably it's what we generally it's a bit of a learning area for me, such as hydrogen, we've got time and actions and trying to understand what it's telling. So I get the impression we're going to be quite a big producer across Europe, just sort of around that environment. I mean, thinking that yeah, HS one then the channel to them still gross the use and passenger traffic and the seals exporting hydrogen methanol sustainable aviation fuel.
So from memory, there are specific things related to dangerous goods and the Channel Tunnel. I might be wrong. But I think, well, to be honest, we have the same with the Southern Tunnel here as well. I think that's a really good question. I think it's equally, if you look at, for example, the carbon capture market as well, where the UK could become a significant net importer, and that's the whole part of kind of the, you know, the business model as well. So I think it's up there. I suspect it'd be one way, perhaps the domestic market develops first, and then as we kind of establish the infrastructure and capability, it then becomes something that, you know, some of the other new energies as well.
I suspect as well, you know, post Brexit, we've seen a lot more short seats in the UK from certainly, you know, Germany, Poland, that side of the European mainland, and that's brought new rail flows with it. And again, from PD, who, you know, have seen far more railable volumes. Then my expectation is that if it's a containerised solution, either way, you can then ship that through ferries from any of those ports as well. But again, Jeff,
yeah, thanks for that. From there, actually, whether it's actually moving hydrogen as freight to be used for fuel for road purposes, or whether it's the possible amounts of power for moving freight around on rail. I'm not sure people's landing on that.
Yeah. So I think, and Andrew kind of pointed out in his presentation, the big challenge is if you wanted it currently to fuel long distance freight, you need some kind of tender or something. And I think that then presents all sorts of challenges just from an operational point of view and how you do it in the terminal. And you're also potentially losing tonnage in terms of, you know, having to remove wagons to accommodate that as well. So I suppose it's one of the, again, it's back to the chicken and egg, isn't it? Because I suspect some of the transport take that will depend on how much the industry domestically develops, and that if it does develop and we're ultimately moving lots of hydrogen around by rail freight, but then it would naturally lead to different conversations potentially about kind of what it might mean for transport.
Technology will
Yeah.
So.
It's the same with battery technology, and that if you look at where we were 10 years ago or so with battery technology, and where we might be in 10, 20 years, and that's, you know, not just batteries as a its own thing, but part of the solution. Technology is constantly evolving, so who knows? But it's why ultimately things like the Vanguard elections is a really good kind of concept, because actually it's something that could reasonably be deployed quite quickly.
Really see it's.
Yeah.
So it could be do big things there, but I guess the question for me is, having well, I think they're take away from the frame, you know, we talk about a big technological development here to create a path for hydrogen. Actually,
Yeah, and to be honest, so I think what's really interesting about the time table work that we kind of have to happen is, by its very nature, as much as you might be looking at specific origin and destination, what you'll end up with is core access that you can ultimately say, right, it's path there, it's a path forward path there, and ultimately, you know, that's not a waste of exercise in general, because it then becomes, you know, it could be for all the rest of the strategic path, it could be deployed in any number of ways. But I think you're right, that there is a real risk that if you don't do that work now and kind of send it to the first one, I think there might be challenges. By the time people have committed and have kind of gone full in, you can't really then, as an industry, start saying, you know what, I know 5 years ago I said you could do it, but no, you can't.
So I think that mapping that we talked about,
Yeah.
where the sites are well connected.
Yeah, I absolutely agree.
I mean, look, we'll move on to my next question. I mean, I took the question a little bit the other way, which is we've got a government who said, well, they've published a target for rail freight growth. And then they look at you and where's that going to come from then? Because you know there aren't any paths, and you know this, and you know that, and you know the other. And you can't get them, well, you've just published a clean energy strategy, or you've said you want to build 1.5 million homes or whatever else. So actually, that's where the growth's going to come. The growth's going to come from your missions that you want, or whatever the next government wants, and well beyond that, I expect we'll swing it around. But actually, we need government to believe that we'll be moving hydrogen and carbon and stuff, and that it's a realistic prospect, which I believe it is, in order to justify the growth targets that then unlock the investment that the railways need. Otherwise, we're just on an ever-decreasing circle, I think. So being able to demonstrate this, yes, it's uncertain, but actually what we've got here is a bundle of producers and a bundle of users sitting on often already rail connected sites, moving stuff that can go in a railable format because it already does elsewhere in the world.
Yeah, and that's really important. It's been quite interesting in terms of our connected sites that when you look at a number of, you know, the former power stations, so kind of Bradford, Swan, Aberthor's another one, they seem to have a common theme in that the developers who are looking to develop them all talk about new energies. And actually it's like, well, okay, that's quite interesting because, like I said, you think you've got a rail connected site that could be finding alternative use, you know, beyond so.
All right, look, let's move on, and then we'll come back to some more questions. I'm sure we've got Helen, who's going to talk to us after lunch about some of the overlap actually between putting it in the tank and putting it behind the tank, and some of the things that are common in that space. But our final speaker before we do some more questions and lunch is Robert Edge, who's a clean energy specialist with a number of different hats I've come to understand, but today I believe wearing the Freeport East hat. Yeah. So Robert, thank you ever so much. Freeport East, I'm sure Robert will explain, very much involved in hydrogen production.
Does the
that's
business?
that's you are.
Hello, Wembley meeting. Oh, you can hear me? Oh, right, good. Okay, nice, thank you. Right, okay, well, thanks for hearing me out today. I just want to talk to you briefly about the different free ports around the UK. Coincidentally, the vast majority of them have either got hydrogen developments taking place either within the free ports or just outside their hinterlands. So I know there is a lot of inland production as well. You might think, how does East Midlands qualify for a free port? Well, that's because East Midlands Airport is the UK's third largest freight airport after Heathrow and Stansted, and it's actually the largest airport which which accommodates pure freighter aircraft. So that's why it was chosen by a chap called Rishi Sunak long before he became the Chancellor, who set up the Free Ports Initiative. I'm not going to talk in great detail about what the free ports offer, but that'll become, this is the free tax sites that we have in Freeport East. So if you're familiar, the rail siding in Harwich just comes to the north. We've had Hillmansen, which is a site of one of our hydrogen projects being mentioned. Hillmansen is about 1 kilometre to the north of the quay in Harwich. You've got Felixstowe, fairly close to the rail terminal as the tax site. And then you've got Gateway 14 at Stone Market, which very helpfully is about 3 miles away from the nearest rail siding, but doesn't choose as a tax site. So basically, the tax site benefits for the free ports are aimed as a tool for economic regeneration from all the free ports that I've just listed. So I'm not going to go through this in great detail as we're going to be sharing the slides, but effectively you get 100% tax relief if you've got any investment located on free port. You don't pay business rates for 5 years, as long as the company first becomes liable by the 30th of September 31. But the crucial thing is for the incentives is that the free ports and their hinterlands, public and private sector owners, can actually use this money for economic regeneration. We're also challenged with promoting the low carbon economy, clean energy and innovation, which is one of the reasons why I have a job for 3 days a week. So these are the incentives. Those are available in all of the free ports that I mentioned. We mentioned there's one on the Humber, ABP, I think they're here, and they're quite prominent in that. There's another one, obviously, on Birmingham, but BD Ports on the attendee list again. Now, the important thing to recognise, though, is that we don't own the land. We administer on behalf of the government the tax site benefits. But at the end of the day, it's up to an occupier to come to a commercial agreement with the landowner. And that's quite important because one of the things that the government were quite keen to do with free ports is encourage investment where it wasn't previously coming to the UK. In other words, using it as an incentive, a policy lever. In other words, you don't want to have somebody who's cheesed off with their landlord in Nottingham moving up the road to Derby or anything like that. So hydrogen, as colleagues have mentioned, it's pain to transport, and ideally, you go back to 1976, you got it produced where you needed to use it, oil refineries, steel works, ideally on site. And that was what powered the historical, or one of the elements of the historic petrochemical growth in the northeast and in Humberside. We talked about it. To make blue hydrogen, we talked about carbon capture. And if you can't produce it where you need it, try to get it there with a pipeline. And there is currently one pipeline being developed in the UK at the moment. It's 2 kilometres and it's being produced by Exxon, who some of you may use for transporting aviation fuel. And they've got 2 sites in Immingham, Immingham North and Immingham South, which crosses a little bit of land owned by ABP, and they've got some innovative funding, I think, for the 3-kilometre pipeline to see how they get on. But obviously, if you use renewable electricity, as other people have spoken about, you can make green hydrogen by firing an electrolyser which separates hydrogen from oxygen. But they're growing use cases, and that's what really got the east of England excited about hydrogen, because we don't have legacy production, we don't have a petrochemical cluster, we don't have any steel making, we don't have any paper making, we don't have any glass making. We've got some very nice pubs, we've got some thatched cottages, we've got a dirty great container port, and we've got an existing nuclear power station and one being built. that wants to be Britain's biggest green building site. So this just gives you an indication of the three ports, the electrolyser developments under development in the various free ports. That's not an exclusive list, but I'm not very good at drawing maps. Now, there is plans for a pipeline which is called Project Union, which is effectively the white lines on this map objective from National Gas. And the reason, the challenge of building a hydrogen pipeline route is the fact that a hydrogen molecule is about something like 1/8 of the size of a methane molecule. So in other words, if you've got a pipe join or a valve or a connection like that, which is fine for methane, there's a good chance it won't be fine if you try to put hydrogen through it. People are planning at the moment for blending hydrogen with methane. Everybody thinks it should work theoretically, but it's a question of going from the theoretical to the practical, and nobody wants to sign the piece of paper. The government's supposed to take a view later this year on trials of a 20% hydrogen blend with methane to see how things get on. So effectively, what's going to be with these 1,500 miles of the hydrogen routes, which National Gas and a number of local gas distribution companies are talking about, is not necessarily building 1,500 miles of pipeline, but getting fibre reinforced plastic to act as a sleeve to go inside existing methane pipelines to accommodate hydrogen. I think that, you can see the white lines on that map gives you an idea of where the distributions are. And as you can see, Freeport East, we're not currently on the pipeline, and neither are some of the other developments on the East Coast, Simpson and Felixstowe and Harwich. Now, we're not overly upset about that, because one of the things that we have in Felixstowe is existing supply chain of container movements in and out of the port, as well as road movements as well. And obviously, with apologies to Network Rail, I've nicked this off your website. That gives you an indication of where you can move things in and out of. But this doesn't. We've talked, this is what happens when you ask AI to say, okay, what does a hydrogen wagon look like? And I got some very interesting responses. I got somebody saying, oh, well, we can't find a picture of a hydrogen wagon, but here's an ammonia carrying wagon, and you can take separate the hydrogen from the nitrogen in ammonia, and then you've got hydrogen. So I don't know where it found this. I don't know whether it's whether it just nicked those graduates design that those graduate done in a piece of work or something. But anyway, that gives you an indication of the challenge. Now, this exists in reality. We've spoken about tube trailers. Now, approximately, if you want to carry a ton of gaseous hydrogen at 350 bar, that will cost you the best part of £1 million. Smaller trailers are available, and to give you an indication, if you had the Scotch Power Renewables electrolyser in the port of Felixstowe working at full tilt, which is 100 megawatts, you're going to need 44 trucks a day if you haven't got a pipeline or a rail way of moving the hydrogen out of the site. Obviously, some of that is going to be used within the port of Felixstowe. They're looking at decarbonising port vehicles, but you do have a challenge at the moment with, in terms of the fact, certainly in our part of the world, we don't really have the land to build a sustainable aviation fuel plant or a methanol plant, because we don't have the legacy expertise or land to do so. We could probably choose like a few patch cottage owners, but not really worth it at the moment. Okay, so we do have an Australian inward investor in Freeport East who actually uses a byproduct from the iron ore mining process to manufacture a smart sponge or what you call in scientific language, metal organic frameworks. And what they are working on in Harwich at the moment is finding ways of building tanks that can actually carry hydrogen at 50 bar pressure. Because obviously, if you have to pressurise the hydrogen at 350 or 700 bar, you need to get a compressor operating. There's capital costs involved there. There are energy costs as well as financial costs to do that. So they've been quite successful at the moment in the marine sector. So they're doing a couple of trials, one of which powering with hydrogen a generator in some of the smaller ports around the UK that don't have enough grid connectivity to run ship systems while they're on harbour. And another one is actually going back to steam engines for work boats. So the sort of things that use on the wind farm support boat, they're actually working with a company who's developed a steam turbine powered by hydrogen. So we're actually going back to steamships, probably about just over 100 years after the last steamship stopped sailing between Harwich and the Hook of Holland. They're very keen to partner with a tank wagon manufacturer or operator to try and develop their concept into something a bit concrete. They believe, looking at various specifications they found online, that their technology will be able to convert a 70 cubic metre rail wagon to carry about 2.3 tonnes of hydrogen, which is roughly about 2 and a bit times as much as the biggest tube trailer. But obviously there's one thing coming up with an idea and there's another thing talking to people who know how to make them. So, declaring interest, I work for RUX for 2 days a week as well as a UK Business Development Manager, but we work quite closely with them. So that's pretty well everything. Thank you for your time, and I look forward to any questions.
Thank you very much, Robert. Thank you. There are some people in the room who make tank containers.
Excellent.
We have them make tank containers. Don't be shy, Greenbrier and BCG, you know the
Yeah,
tank wagon, sorry.
Oh yeah, it would be interesting having a chat with you. I've been reading about what you're going to do in the Deutsche Bahn and Toluene. Yeah.
So that's brilliant. So just before I'll let you go, tell us a little bit. You've got a green corridor with 3/4 East Midlands.
Yes, we
Tell us
have.
a little bit about that.
Well, basically what it is that probably about 6,000 trucks a day going into the East Midlands and from the port of Felixstowe, and probably the best part of 10 trains a day taking containers to Daventry and East Midlands Gateway. And what we're trying to look at is the cleanest way of moving those containers into the East Midlands. So, you know, hydrogen has got a role, electrification has got a role as far as rail is concerned. And we're also looking at hydrogenisation. There's a project called Highball, which you may have heard of, which will actually subsidise the lease for operators of vehicles who want to lease a pure hydrogen truck. The first ones will be coming on the market probably later this year. I think Scania and Mercedes will be launching them. And that will subsidise their lease by about 80% for 5 years. So if you're a haulier and you're indirect, or if you're a rail freight operator with haulage operations and you're interested in getting a subsidised lease to see how you get on with the hydrogen vehicle. Obviously, hydrogen vehicles are, you know, a bit useless if you haven't got a hydrogen refuelling facility. So as part of the project, the developer, which is DFT funded, is actually going to be building a hydrogen vehicle refuelling facility in Great Blakenham, which is about 2 miles west of Ipswich.
Great. Okay, so look, we've got a few minutes before lunch for some more questions from any of our speakers this morning. Let me sort of summarise, I think, what we've heard and then what we're going to comment on. So I think what we've heard is there are lots of people out there, Robert included, involved in electrolysing hydrogen, or will be at scale. And as Andrew's pointed out, there are lots of projects on that map all across the country and more yet to come who are interested both in making it and using it at scale. Some of them sit on rail link sites, some of them don't, some haven't been invented yet. Some will emerge that we haven't thought of yet, but nonetheless, there's a clear and demonstrable movement towards a market. Fair? Right. What we're hearing is it's quite hard to move hydrogen. There might be some pipelines, but not necessarily in all the right places. And that's unproven as well. There are some road vehicles that are very expensive and don't move much. But the technology that you'd use for a very expensive road vehicle could also be used on a rail wagon. There are some people trying to invent new things to do that better. And you can move it as methanol or as ammonia. Did you say something else, Andrew? Another one?
No, well, you could move it as sustainable aviation.
Yeah. So there are different ways we can do that. And those things could be moved either in a wagon or in an ice tank. Right. Okay. So we've got the basis framework of a market. Ralph makes some good points about the economics. So perhaps one of the things that might be worth unpacking in the few minutes we've got is where's government on funding and the the scheme again.
There's a scheme at the moment called the hydrogen production for business model.
Right.
And it's focused predominantly on producers of green hydrogen. And it's simplest way of describing it is it's a contract.
Oh yes, sorry, let me give you the mic.
Contract for difference type model. So it is screen.
Okay.
Yeah,
Yeah.
it's a contract for difference type model similar to what's been kind of applied in the offshore wind sector. So effectively, anybody who wants to apply for this, what you do is as a hydrogen producer, you can work out what you need to sell your hydrogen at with a return on your investment. And if that hydrogen is displacing natural gas, very crudely, the government will cover the difference between the cost of natural gas and your cost of hydrogen production for 15 years. So it's quite an attractive proposition. Now, they implement this hydrogen business model through what they call hydrogen allocation rounds. So they've had one so far, and out of the first hydrogen allocation round, there were, I think, 11 projects selected. And those projects are currently in the process of being, built. Some of which are, coming on stream sooner than others. And as I say, everybody in the hydrogen production industry are sitting there in their seats at the moment waiting for the outcome of hydrogen allocation round 2, where there was something like 87 project applications cleared. And each allocation round has a total capacity. So I think first allocation round had a total capacity limit of 100. Or was that 125?
Yeah.
125 megawatts. The second one is 850 megawatts. And I think those 87 projects that were submitted, I think exceeded. I think it was about 2 or 3 gigawatts worth of capacity. So not all of them will go through.
No.
But obviously, the industry is hoping that a good chunk of those will go through. And if they get through, then they have to. They will have already agreed with the government that their project will be on stream by a certain date and operating.
And that mechanism then that guarantees the price they can sell it in underwrites their investment in the physical impact.
Yes, yeah. And also it's worth mentioning that the government is also working on a hydrogen transport business model and a hydrogen storage business model. And in my humble opinion, I don't know why they decided to break it down into those kind of things, because you can't have hydrogen production without storage. But anyway, so soon there will be coming out, I think by the end of the year, a hydrogen production business model, a hydrogen storage business model, and even one on hydrogen for power business model. So the intention being that the government wants to see the hydrogen sector, kind of established, but obviously it's where we are at the moment, it's very hard economically to do that without some incentive from the government to help to make that happen.
So will any, sorry, I'm monologuing here, so I'm asking the sort of questions, but within that framework, do you think there's a place where rail wagons, already road wagons, can be underwritten through that effectively?
That's a good question. I would have thought the obvious place for that would be in the hydrogen transport business model. But all I've heard so far, and this is in kind of development at the moment, so this may be a good opportunity for RFG to lobby government to have this included, but all I've heard around the hydrogen production transport business model is that it's focused on pipelines.
I think it's also fair to mention that one of the hydrogen allocation round one projects, which Scotch Power Renewables have done in, I think, the place called Whiteley on Dumfries and Galloway, which is probably about 30 miles away from the nearest potential volume gas user off the gas grid, but they've got an onshore wind farm there that can produce the hydrogen. Is that their bid actually included, I think, for a couple of purchases of a couple of tube trailers to move the hydrogen from the electrolyser. So they managed to get that one away. That's what I'm saying.
I'm surprised they managed to get the tube trailers included, because what I'm hearing is Desnes clearly Desnes wants to minimise how much the difference between what the hydrogen producer wants and the natural gas. But they take the view that tube trailers and anything to do with transport is not production, and therefore is excluded from the costs.
Andrew,
Yeah.
Thank you.
As you know, I
There you are, Andrew. I know better than I.
so I came to one of these meetings last year to talk about how we put more freight onto rail. Not hydrogen, by the way. I work for RFG Logistics, and we work in distribution for a number of multiple businesses. The problem will always be you're competing with road, and road is cheaper than road. Unless you can put multiple wagons on a train, multiple boxes or tubes on a train. So I think that the biggest target should be actual trains themselves, or the conundrum that was raised earlier. Should it be carrying it around, or should it be to the carriers? I think it should be to the carriers, personally. And one of our customers is Rise, and Rise are a part of they're building a site in Bradford, which will be ready in 2027, and will easily double the amount of hydrogen already made. Okay. So there will be a number of those around the country by the time 2027 or 2028 comes along. And I then don't see the reason why you would want to move it around the country on rail. It would be a short journey by road rather than rail, I think. So therefore, the focus should be on how do we make a hydrogen train or hydrogen road vehicles or nuclear power stations. So that's my opinion.
Yeah, I mean, I think there's a place for both themselves. I mean, you know, I'm yet to be convinced that we can get enough power out of hydrogen to pull half the kilometres on a freight train at 75 miles an hour. That's got to be proven as well.
Well, of course, I mean, that's all well and good if you've got the railhead, you know, to be able to, you know, we've got to go via road at some point to get to the railhead, to then get to another railhead to move it to its final destination.
On some routes, on some routes. So Freeport East,
Yeah, I mean.
railhead.
Yeah, I mean, we have got a railhead. I mean, it'll probably take a while to fill up the trains. That's why we want to be selling individual wagons. But I am aware that Exaloom on the Humber are looking at the bulk distribution predominantly of sustainable aviation fuel. Because they're only connected, I think, to 3 of Britain's airports by pipeline. Everything else goes via road and rail, so it goes to the nearest railhead and then decanted into a tanker to take it to the airport if the airport can't receive it by pipeline.
And Greg, dangerous goods, can you put a ice tank of hydrogen on a normal intermodal train? Big up. Can't bother to walk down out of Mike.
Kind of that's just linked to the stone theory.
Yeah.
I'm going in the same way that obviously it's slightly different, but as a vegetarian, you look at the Tesco trying to get into Inverness, it regularly moves about 500 gas and take it over as well. So it's important for people I've seen.
So let's, you know, if Rooks get it right,
Yeah.
squeeze it all into their magic sponge,
Magic sponge, yes.
chuck it on a train at Felixstowe, get it off the train at East Midlands Gateway, jobs are good.
Yeah.
Right.
I would also mention that other magic sponges are available. And in fact, there is more, about 70% of the underlying chemistry for moths or magic sponges is identical both for storing CO2 for carbon capture and storage, as well as for hydrogen. RUX, because they're a small Australian startup, have chosen to prioritise their research assets to into hydrogen. But you know, if somebody can crack even more magic super sponge that can carry hydrogen one way and carbon the other way, so you can move hydrogen into an industrial use by rail, and then capture the carbon and move it out, capture the carbon out, get it repurposed. Perhaps if we get some more investment, we'll have a look at that one ourselves. But at the moment, I know, in fact, a number of the other moth companies are attracting investment from big petroleum players. There's a company in Cambridge called Immaterial that recently got a round of funding from Chevron Ventures. And Chevron don't currently have any electrolytic hydrogen capacity under development. Not they told anybody anyway.
But you've sold me on it, magic sponge is going to be my
Magic sponge is
now. That's coming on and then we'll go to
It's worth mentioning that some of the kind of new generation of tube trailers are designed with inside ISO containers. So they can be lifted off the chassis and either put on the ground or put on presumably on a rail car.
Yeah.
So, you know, I know we've looked at projects in Europe where, you know, the client was developing a project where they were going to take the initial, you know, kind of hydrogen, the first few miles to a railhead, the language, sorry, and then take it off the back of the train transport. So people are thinking about this and in the design of their trains.
I was just going to sort of reiterate what Andrew said there. And so I'm Chris from Expert Logistics. We move about 7,000 movements of containerised hydrogen a year. So we're doing millions of miles on the road network. We're looking to put them on the rail. I think the difficulty for us is people want a full train. We're not talking about taking a full train, we're talking about 1 or 2 containers going from northwest up to Scotland to decarbonise the journey. We work with RISE and too, so they're using Calvera, using your ISO containers. I think there's sort of 2 conversations here. There's the technology and what it might be, but there is a large industry of what's actually happening now, and how do we transport that on the rail? That's why we're here today.
Yes, I mean, look, it seems to me there's an obvious thing there about unpacking what's the art of the possible right now with what's already in a railable container, whatever it is.
Because a lot of the information on the screen is all on technology, the new stuff that the newer companies like BLC have invested in 20 years ago into trailers. The new containers and the LP one that's on screen is 20-year-old technology. The new stuff that Rise, Element 2 and some of the new people are using carbon fibre trailers with higher capacity, higher density, and therefore it makes a little bit more sense. So,
The advantage of using carbon fibre, of course, is that if you are carrying your hydrogen at lower pressure, then you don't need to have a inner on inside the tank.
Right, so look, sandwiches here, everyone's been waving at me, she's sat down now, which means they're definitely here, so I think we should break for lunch, but I think that, you know, those of you who are already moving containers, some conversations clearly to be had here about the viability of putting hydrogen containers next to non-Lewis containers or whatever else it is you're moving, why not? So I can see David from Freightliner in here, I've got DB right behind you, anyone here from GB today? No, John, you don't own boxes, do you? No, Jeff, you do boxes. Right, so there's some people here who are already moving containers, so they're there. Some wagon people here, you might want to catch up with over a sandwich on magic sponges. The answer to any problem though is magic sponges. When my daughter's asking my cash later, that's going to be my answer now. It's I'm sold on that one. But have you got an hour for lunch, Yvonne?
It's 1 o'clock.
Yeah, back at 1 o'clock or thereabouts.
Really will explain.
Yeah, right.
So I just
Yeah.
have the microphone and
Just a sec, folks. We've got next. Just a sec.
Thank you. So anybody with we've got sandwiches, well, actually, no, there's one who's got sandwiches.
Yeah.
We're going to be going through the building into our kitchen area where all the food's laid out. So it means that we'll be going through our access control door. So do follow me and maybe I guess find that's one of them, just to make sure nobody gets lost.
Yeah.
If you do need to use the facility, there are some more toilets removed from the kitchen area, so you don't need to come back this way. It is a lovely day, so please feel free to take advantage of the sunshine. Birmingham doesn't often get it, so you know. In which case, just come. You'll come straight back through here. There's a green door release button on the right hand side, which will let you back through. And then we can, if you'd like, I can relock these doors as well, so your possessions will be safe. So you can leave your bags and your laptops, things if you wish to. But then if you do want to come through, then you just have to give me a shout. So I'm Jenny. If I'm not in the kitchen area, I will be in the first office that we'll be walking through. And you can see where my desk is because there's a little EU flag that says, might then also get an idea of which way I go to. But enjoy lunch. Have a word. If you see any strange looking people with orange lanyards, we're not too scary. Do feel free to say hello if you wish. But then some of them are a bit weird. So enjoy lunch. We'll pause the recording as well. Yeah.
All right. Oh, just afterwards. All right, ready? For you.
This version of the Hydrogen project that you've heard about today, so the prototype and the mainline version as well. I'm now working closely with our team at Vanguard who have the hydrogen approach earlier projects. So we're working on lots of different hydrogen train technology projects, both in the UK and overseas. So it's got a lot of the other thing that's not really being mentioned today is this is all happening internationally as well as in the UK. So there is a real growing market for hydrogen trains as well as means to transport hydrogen. So we're currently looking at our team looking at an Innovate UK funded project about tube trailers and whether we can put those onto a standard rail wagon or what we have to do to allow that. And then there's a little bit of conversation about that this morning. So I'm just looking at those things. So I'll talk a little bit about what's used today to put hydrogen around. What are the barriers to transporting hydrogen rail? What does everyone get worried about? So we'll tackle some of those big questions. And then where are the opportunities which I hopefully lead into a panel discussion about that, Maggie. Right, if you want to transport a small amount of hydrogen, we'll use one of these. They're called multi-cylinder pallets. Now I know there's some people in the room who have been talking and had a lot of experience of hydrogen, so this is all familiar stuff, but I'm really aware of this completely new topic to you. Knowing how it happens today is quite useful. So these are commonly used in industrial applications. They take typically around 20 kilograms, really small quantities, but are quite useful for transporting it, and that's a compressed gas storage, 250 bars. And they're delivered to your site wherever you want them delivered on the back of a flatbed truck, and the operator needs a special licence to do that. But that's really common practice, and you will see those going around on the road network today. You store them on site in the same way that you do with other common gases, but the MCB forms the cage structure, so you don't need a specialist compounder. The other one that got mentioned today was road transport by tube trailer. So this is a photo of the tube trailer that's used to fuel hydroflex, and inside that it looks just like a normal road lorry. You wouldn't really know other than the giant hydrogen label on the side what's inside it. But inside there are a series of those tubes, those high pressure cylinders. This one can store up to 350 bar. It's commonly going up to 700 bar now in the automotive sector. So we're seeing a lot more of these, even though they have got quite a high price tag that was mentioned earlier. This one's about, we get about 300 kilograms of useful hydrogen off it using the count mechanism, but they can go up to a time which was mentioned earlier. So there's a variety of these. These get transported by specialists for over 4 years. The project that we're going to do within the UK is going to look at taking one of these and kind of going directly onto the flatbed wagons, or what would we need to do from an internet wagon. So what are the steps we need to do to consider? The next thing that's coming, we haven't mentioned very much at all, is liquid hydrogen. So there's not very much of this in the UK at all at the moment. It's used a little bit in industrial process applications. It's got a much better energy density than hydrogen. So somebody else, I can't remember who it was, asked a question about the density and whether it's worth even transporting gaseous hydrogen. This is where liquid hydrogen comes in. The disadvantage is the boiling point of hydrogen is very, very, very cold. So they are stored in big tanks, and those tanks are thermally insulated for transportation. That means you've got to consider things like boil off, because at some point you will lose some through evaporation, so the tank has to be capable of dealing with that. The interesting bit for the room today, I guess, is that there are some really large-scale industrial projects, international projects, looking at electrolysis of green hydrogen, particularly in the Middle East. And then those companies are looking to transport using liquid hydrogen through shipping around interport. So I guess this is we're not here yet, but this might be worth looking at in the next 5 years or so as the industry develops. So as hydrogen develops, and all the things we've heard about this morning, then this is going to come as the next thing, I think. So whenever I do anything on hydrogen, I've been in hydrogen projects on Traceback 7 years now. 50% of the people you speak to mention the Hillmansen in the first 2 minutes of the conversation. So let's get that out of the way first of all. So won't it explode or catch fire? So the Hindenburg is a really, really dreadful way to transport hydrogen. Let me just say that at the start. If you're going to transport hydrogen, don't put it in with an airship, which is covered in a flammable fabric and coated in a lacquer that catches fire. So the Hindenburg was caused by a lightning strike catching fire to a flammable coating on the airship. So the first thing is, that's not really relevant to us because the flames have got hydrogen there. So that's the first thing to say. Having said that, you do need to think really carefully about flammability and explosion risk with hydrogen. So hydrogen has a lower flammability of around 4% in there. So that's 4% concentration in there. It's typically when it starts to become flammable. And it's explosive somewhere between 17 and 18%. Now the 4% isn't too difficult to manage because there are some other gases that we're all familiar with that are flammable around 6%, and that's not too different from other gases that you're more familiar with. The explosive level is much lower for hydrogen than some of those other gases. So the really important thing to think about if you're transporting and managing hydrogen is not to let it build up to an explosive level and to allow it to be well ventilated and out in the open air. As the other property of hydrogen, we have something really small molecule, we go back to chemistry day, it's really low down the periodic table, is very, very buoyant. So as soon as it gets into the atmosphere, it's up and away and dissipates extremely quickly. I think on the hydrogen, we had a 350 bar tank, if it comes out with, comes out with a tank on there, it exits upwards at 45 miles an hour. So it's up and out of the way very, very quickly, and it dissipates very, very quickly. So you can model but gas release events, and this is really the bit that the work that we have to do. If we're going to transport by rail, we have to think about the risk assessments on it. So what are the big risks? One, it might leak, so we've got to think about gas release events. Two, we've got to consider the crashworthiness and collisions around and big consequence impacts and things to worry about. And finally, the emergency response to hydrogen is probably going to be a bit different to anything else. So if we look at those things in turn, and we say gas release events, well, a small leak would probably be able to show that it would just dissipate and there was no issue at all. It wouldn't even matter really where it was. We just know it goes out of the open air and dissipates. The problem there would probably be, would you want to know about a small leak and how would you detect it? So those are the things you might want to think about, sensors on vents or exits or something to the tank. So thinking that through. The second one, larger leaks, this is like a tank rupture or a valve release, so that all of the gas in one of those tube cylinders dissipates in one go. Then that you can model using CFD techniques, you can model the gas cloud and concentration that you would get. And then we've modelled that at different speeds of train. So you can get some interesting analysis done on whether you actually reach the flammability level or the explosive level, depending on the speed of the train. And when we did this model before light effects, and when we did that, we showed that if you keep moving, the train is moving, then actually that's a better situation because it's dissipating and you don't actually reach those flammable levels. So you can show a case that is very, very safe. Now, the interesting bit is tunnels and covered stations. So what happens if you get a big leak and you're inside a tunnel and it's all a disaster on it? Well, we have to then start looking at risk and probability. So the methods used are all aligned to the risk assessment processes in the common safety method. And you can look at RSSB data on time to failure and consequence versus the likelihood of something occurring. And you can actually calculate the risk of a derailment happening at a tunnel, a collision happening at a tunnel. And then you can go back to the manufacturer of the tanks and the data sheets and all of those bits of data and look at how likely is it that you're going to get a big in a tunnel in these scenarios. And you can make a case that shows that it is safe. And this is how you work your way through the justification for this. So I can tell you it's entirely possible to do this, right? We've done it several times now. And you can make a case to show that even for the big leaks, you're very, very, very unlikely, and you're up in the 1 to 10,000 year category, that this is going to happen inside a tunnel at the moment you get a big leak. But the design of your tank matters, and then how you're going to report on these things matters. Are you going to be alerted if there's a leak, or are you going to know about it, so that maybe the driver knows in advance for the tunnel to stop before the tunnel. In the same way that you would fire on the train. So some things to think through there a little bit for the transport of hydrogen, because that's a little bit different, and we need to compare that against other dangerous goods that we already transport around and make sure that we're doing a comparable safety analysis on those. Crashworthiness is quite interesting because there's been a few incidents over the 30 years of collisions involving tank and wagons, where the main risk has been I'm thinking of hydrogen particularly, the main risk would be an overriding event where the buffer faces detach and the buffer figures penetrate the wagon with the tank wagon. So I think that's probably the biggest risk in this to look at as we think about this tube train going onto a standard wagon. Is how do we mitigate against overriding and buffer penetration on the tanks. So that's what I'm expecting this project to look at those things. But those things are entirely, we can get around those, we can design those out through override protection. And think about the standards which are going on any dangerous goods trade, they have overriding protection. In fact, it's been on them to stop the buffers coming into the tank. And the third thing on there is emergency response. So this is about what does the driver do when there's been an incident? What does the ops control staff do when there's been an incident? What does the emergency services need to do? A hydrogen train. Now there are a little bit of different actions that you probably take. So a lot of the actions are exactly the same you would do with any emergency of a dangerous goods train or any emergency of a fire or something else. So you can follow the standard processes wherever possible. There's a few things we want to probably know differently, particularly in the emergency services we want to know differently, depending on the location where the incident had occurred. So thinking those things through is really important. So that response and how they do it. And some really good HSE research into tunnels through emergency response workers. So hydrogen events in tunnels, there's a project called High Tunnel that's run by the HSE, and you can look at those findings to see what the emergency services need to know in the event of an incident. So I think you need to go through a full risk assessment, and the next one is we already do dangerous goods, as I mentioned before. Those are the bits of you will look on our SSB website, the relevant standards and things. But the process needs to be followed for any new freight flows. If we're doing new container types or new wagon types, if hydrogen is new to a particular operator, so it's you've never as an operator, you've never carried hydrogen before, then you have to follow the process. And the process basically says do a risk assessment, think about safety, think about all those things we've just talked through, and document why what you're doing is safe, so you've got that safety justification. And that's what I find point of this safety stuff is the rail industry is really good at this. We're really good at doing risk assessments. We do them all the time. We think about risk in the right way. We've got processes and standards that allow us to follow these things. We already have a dangerous goods process that calls up a risk assessment process. So we're in the right way of thinking about this. This is not impossible. It just needs thinking about carefully. So I think, look, I'll just leave you with the opportunities around modal shift. Hydrogen, I've heard a lot of growth statistics about the hydrogen economy. That's all coming to the UK. We can see it in other countries as well. We know this is coming. There's a modal shift opportunity to put some of that road traffic for the tube trailers onto rail. And maybe we want some containers, purpose-built containers in the longer run if the market is there to serve that. We're already connected to major ports, so if we're importing hydrogen from other sectors and liquid hydrogen is coming in at ports, they're all rail connected anyway. We've got a lot of good connections for a lot of the sites that were on those maps this morning. There's an increasing demand, and we've got an opportunity to demonstrate our value to the other oil and gas sector. And the moment to demonstrate is coming up fairly soon, isn't it? It's great to have this conference today because we're starting that process of collecting our pitch as rail to the oil and gas sector. So we're not in competition with each other, we're in competition with other sectors. So I think there's an opportunity to do some kind of trial with a tube trailer, because that would really, there's nothing says we can really do this by government showing people. So I think if we could do something following on from this piece of work to do a trial, that would be really powerful. And longer term, maybe we need to create a case for investment into some new wagon types and ways to transport hydrogen. So I think that's what I wanted to say. It's a bit about safety and all the barriers and things. So I think we'll probably have a question.
Thank you, Helen. Let's take direct questions to Helen now, and then we'll switch to the panel and we can take some more wider ones about everything we've heard. So, questions for Helen. I know you sandwiches are all settling to Boston.
And I've talked about safety as
Well,
well.
words.
I think just a very brief observation.
Hang on.
Get shot by the It's just a very brief observation, thanks Maggie. Thanks, Helen. We talked about this, safety and my spirit colleagues say we don't share sort of the politics of it and the optics of it. And when I work for politicians, I think it's increasing well, with people achieving their own ways. Safer than road, I mean, that's a massive selling point. I mean, my council spends on every day, say there's 2 red lines and red line and so I think again, there's potential as a positive point, isn't it? Well, an accident on the A54 or the M40 is probably going to be quite challenging, whereas if it's on the road, it happens very infrequently and we're probably quite good at dealing with these.
Yeah, and I think the thing to note obviously because these tube trailers are going around my road now, next to drivers who are partially trained to a certain standard, but we definitely do better than that in rail. We've already got these procedures in place for managing dangerous goods train because we do it safely every day.
Can we take one of those through a tunnel on the road?
It gets through tunnels. And that's one of the things the High Tunnel project was looking to see how emergency workers should respond if there was a hydrogen tube trailer crash in the tunnel on the road. So that's one of the things they looked at.
Any more questions, Karen? Yeah, fine.
I look like aggregate industries. So I guess you made the point in terms of the railway is very good at doing risk assessments and identifying safety risks and how to manage them. I suspect in terms of saying it is safe that the road is a bit weaker than it could be, it's materially safer.
Yes.
By how much is the question, and it's the extent to which rail as a mode is able to leverage what might be 4, 5, 10 times safer in a measured way.
Yes.
To UK government to get behind rail as being the mode of choice, or one of the modes of choice.
Yeah, there are stats published on that. I can't remember the numbers of the top of it, but they're on the RFG website and the publication say we can definitively give you
Robert. Right to the mic. Sorry back, Robin. Sorry, we're getting you stuck count up.
Yes, thanks. One of the issues with tube trailers is every 5 years they need to be virtually sort of taken to bits and reassembled and revalidated before they can be certified. Do you see that the process is exactly going to be exactly the same with the railway wagon?
There are different standards that the tube trailers are built to the standards we use in rail. So the first job is a comparison of the gap analysis between those two sets of standards. There are also there's another bit of legislation around pressure vessels regulations that apply for the rail vehicles have to meet pressure vessel regulations. So there are 2 routes here with 2 different regulatory pathways. So when we decided on the final solution of whatever design it is that we want for rail, then we're going to have to navigate a path to compliance that comes up with something sensible and practical for a railway application that also meets the standards we expect in rail. So I'm sorry, that's not a clear yes or no answer. I think that's I don't know the answer quite yet, but it's a direction we need to work out. Yeah, they've just got a different approach in automotive to rail, whereas we have a kind of we demonstrate it back a lot more through failure rates and analysis to back up the risk assessment. The numbers used in rail as automotive is so much higher than in rail applications, and we've got a higher load case. So it's just a very different thing. Sorry, that's not very well explained.
And how if we're going to a terminal and we're unloading a tank container, that doesn't assume it's one of those. Are there any regulations about the terminal we need to comply with?
It depends on the amount of stored hydrogen you've got. So the COMA regulations come into force when you get a collection of hydrogen in an area. So I think that's around 9 tonnes. from my head. So once you get to a certain volume or mass of hydrogen in an area, RSFE have done some really good research on this, looking at whether it would apply or wouldn't apply, and the transport, if it's used as a fuel, no, it doesn't apply. If it's used as a fuel and just in a vehicle ready to be used, it doesn't apply. But if you're transporting it for another purpose as a normal goods train, then potentially it's a little bit of a grey area once you get into the storage of it.
David, did you want to come in on that?
Maggie, yeah, you just sort of slightly stole my question. The 5 ton limit is the lower limit, and then we've got the 50 ton as the upper limit. My understanding is that the density of the material is quite important here, so the actual density of hydrogen is quite low in some of these units, so it's a scenario where it's able to be stored under the lower sort of threshold.
Yeah, it would need looking at, wouldn't it, for an area, but you're right, there is this 5 ton.
Yeah.
You start to get into doing any of the code assessment or not, that's kind of a question.
I think a code assessment would probably be valid.
But you'd have to prove you didn't
Yeah,
need one at the very
very
least, wouldn't you, yeah?
So
There is some good stuff on the RSSB website if anybody wants to look at that.
So I'm going to take another question if I may, thank you. We've talked about rail capability, and we haven't necessarily talked about a road and rail type unit. We talked about isotypes and combinations. The images that have been on screen seem to be an ISO type design. They also seem to be quite low in terms of their height. So we're used to dealing with 2.5 metre sort of high units. It strikes me as if there's an opportunity there for almost to go anywhere, sort of hydrogen tank, any route anywhere in the country. And is that probably the best route combined intermodal type unit rather than a rail?
Yeah, I think that's the way you go, wouldn't it? At least have a product, two-tanker product that could do both road and rail and go anywhere, because you've then got the flexibility to serve local markets once you've done it to the nearby rail freight and everything. So I absolutely, I think that's the way forward. Yeah.
Just a quick supplementary to David's question. If you do that, given the waste that's relatively low in these tanks as well, considerations to your trains as well, you know, trail a lot more. Just one of the issues there is.
Chris, what units you're moving, how high are they?
They're actually really heavy.
Right.
The containment is the issue.
Yeah,
You're ending
right.
up with before some limit on the road. The issue is the reach is that the containment is so heavy. That's why you can only get 700 kilos per hour. Because you reach the 40 volts limit with a unit and it's a scaling trail. So we have to go down the route of lightweight scaling. It's lightweight carbon fibre.
Did you get that at the back? Of the units that you're moving today, are they standard ISO or are they bespoke? 8.6 or 9.6 or 8.4?
They are moved in Europe on the rail.
You know how high they are?
So it's 2.4 and it depends again, the element 2 one is one of ours.
Okay. So they're not the biggest. Sorry, I'm getting really boring with that container sizes, forgive me.
No, but they can't be any bigger because the containment's too heavy.
Right.
So the issue is that you could, they've not even got the full complement of Tueston because of the UK road limits. So you reach the threshold of the top.
And there's perhaps opportunities to make in 20 and modular version where they would be adapted.
So the idea would be to use the road on the rail.
Yes, so for half the UK network, you can do a 44.2 9.6 line shipping container, and half the UK network you can't. So the lower they are, the more routes you can go on. Yeah. Cool.
So that's why I think it's out really well.
Yeah.
Because of the one design. So
Of course, it's even lower road line, isn't it? But don't ever invite me to dinner afternoon, so right. All right, any more direct questions for Helen, or shall we move on to a wider panel debate? No, okay, in which case, Helen, why don't you join the panel? Let's grab an extra chair. Greg, and then also Lee and Ross, do you want to come up and take a seat? Right, I'm going to give you that one to hand around, and then Robin should keep the roving light when we get questions. So look, we've sort of entitled this panel "How to Make Progress," but really, I just thought to get some people who are expert across what we've heard, reflect on what they've heard, and also sort of think about where we might take this almost. But before I do that, I'm going to ask Lee and Ross to introduce themselves and just say a few words about their perspectives, because we've not heard from them. So Lee, let me come to you first.
Yeah. Hi everyone, I'm Lee Armstrong, the head of rail for Associated British Ports. We've got one of the first hydrogen plants being developed in Birmingham as we speak. It's just got its planning consent for the outer the hydrogen plants to be built inside, and that would bring in green ammonia in, but it's hydrogen. So then the questions that I've been listening to today is about, does it make more sense to move the hydrogen to the hinterland and convert it to ammonia to hydrogen inland? I don't know what the economies of that are, but then the hydrogen that is built and all the off products that go with it will all be moved out. So there's a lot of opportunities for everyone in that area. Some of it shouldn't be able to be moved quite right.
Thanks, Lee. Ross?
Hi everyone. That way you are. My name's Ross. I'm a partner at Burgess Salmon. I'm a colleague of Lydia's. What's that? Except I don't do rail. I specialise in energy, and I do quite a lot of hydrogen projects. Part of the net zero team, of which Lydia is also part. So this is a great opportunity to connect what we're doing with energy, with transport, particularly rail, and see the crostovers between the two. And I'm sitting at the back and still to what everyone's saying, and I guess you're all looking there thinking, is this thing going to happen or not? Is this a business for us or not? What's going to happen? And I can enlighten you on my view of that and also some of the challenges. The main point is that the transport solution has not been solved or addressed yet. So you can look at that as a negative, or you might want to look at it as a big opportunity to get in there and solve an issue that the whole industry is considering at the moment. But my background, just out of interest, just to give you some confidence that these things are happening. I'm working on the High Line West Wales pipeline for Wales and West Utilities. We're working on the High Net project to reduce blue hydrogen. We are working on a huge underground gas storage project for hydrogen. We are working on probably numbering up to 15 green hydrogen projects that will apply for hydrogen allocation 1 and hydrogen allocation 2, or actually renewable transport fuel obligation incentives. And we're involved in a big refueling project on hydrogen RPM 4. So I would say that there are these projects out there. There's a lot of issues around changing governments and maybe possibly wavering support, at least for the moment. But these projects are out there. People are deadly serious about it. So is some of the demand side, actually. So I'll just add that into the mix.
Thank you. And Greg, take the mic to the next. So just sort of taking last panel of the day view. What's your takeaway from what you've heard today, and what do you think we should do next?
So I think Network Rail's in a slightly interesting position in that we can help facilitate a lot of conversations and ultimately help to make stuff happen, but equally we want to be limited in some other ways in terms of actually physically doing some on. And I think it is fair to say that for every opportunity, and there clearly is an opportunity, as being said, there are challenges to overcome. I think for me, there's an element from this about, so I've already heard lots of really positive conversations with people who perhaps haven't met before, which is exactly what this whole event was about. I think there are a number of things we can take place. So for example, some of the work that Helen and Nico are on with in terms of kind of doing those trials and how that might be done. Obviously, network rail potentially has a role to play in terms of facilitating that. So that feels like something that could happen relatively quickly. And I'm a massive believer in kind of if you show people what could be done, it's more likely to happen than if you just talk about it happening. So I think that's however we progress, that feels like quite key thing, because ultimately, if we get to a stage where we've all done everything we can, it still hasn't happened, well, at least we can all be honest with each other and say, you know, it's not for want of trying. I think sometimes it's the case that kind of things seem too far off and too difficult, it doesn't happen as a result of that. I think this is a bit different, and it's the same with the other new energies, albeit I think in those cases, you know, carbon capture and sustainable aviation fuel, there are either things we've done historically by rail or things that are very similar to what we do today by rail, and so it's much easier to visualise what that might look like. Hydrogen is a bit different because, you know, and I do also think we need to think about what's going on the continent. I know DB in Germany are kind of big advocates of moving hydrogen by rail, precisely because you can't always have a production facility where it needs to be supplied, and there will be cases where that is going to be the case, and there isn't going to be a pipeline, in which case, how do you move it if you're not on the coast? It's by rail. So I think, yeah, look, we need to keep the conversations going, and I think there's almost a need of, like I say, with the trials and everything, how do we quickly and efficiently and safely kind of get that to a real thing? Because I'm pretty sure there's people in here, a couple of the ladies can also help make that happen. And the sooner we do it, the sooner we demonstrate it, the more likely people will be knocking on the door.
And Lee, can I quite, you've got a campus planning.
Yeah.
In your conversations with government, so you've got planning and you're in a free sport zone. Are you talking, not you personally, but are ABP talking about the rail potential area?
Well, I mean, we're talking about the rail potential across all the enabling the energy transition, but the hydrogen is the least mature out of all them. Carbon capture and storage is those conversations that are happening. There's under NDA. Rail solutions that have been developed already. Hydrogen seems a long way off from that at the moment. And I think, you know, in today we've come away with more questions than we've come away with answers. And I think for me, it's about trying to auctioneer some of those answers, find out whether it's the people who need the hydrogen or people what's going to be paying to refill, or is it the people that's producing them? You know, that's quite a fundamental thing that you discussed at lunchtime. You know, who are those people that, you know, we identified them and we've got them discussing it. Where do the pipelines would go? You know, British Steel, for example, if some thought if they go to electric car, if they go to electric car, they're going to need additional hydrogen applied, probably go by the pipeline quite efficiently, but there is already rail connections there already, and data services to fix things. So those things haven't really been discussed yet. You know, British Steel electric car still hasn't been finalised. There's so many questions out there, and yet they're yet to be flushed out. So I think the bit for me is that we just need to, as an industry, get closer and start asking those questions. And I think some sort of solution that we can demonstrate go a long way. I think the other bit piece that I did some research for this today was DB Cargo in Germany are moving the hydrogen mixed with the liquids, which I thought that's quite an efficient way of doing it. But if the iron tank is 30 ton, probably isn't. So, you know, it's just probably the nature of the product. It's going to cost a bit to make. It's like with fresh air as well. So I've got to be surrounded by pressure tanks, or to be surrounded by something that keeps you safe. So yeah, another question to be answered.
And Ross, you talked about government going tackled. I mean, that seems to be true of quite a lot of policy areas, so I wouldn't take it personally. But what do we need to do to try and get the rail story over to government back?
No, I think I'm not sure government's going to take it's worried about finances and how it's going to fund things, and it's reacting to a world change around probably less profile of net zero targets for what's going to be a temporary period of time. If you talk to any person who's worth this sort of industry, in the medium term, they all know where it's heading. In fact, we've got a lot of corporates that we work with. We basically say it doesn't really matter what the politicians say, you know where this is going to end up, we're already down the road. This is going to happen, and that's what I'm saying. That I think the demand side is thinking about. It's thinking it much more quickly than it ever did about renewable electricity. You know, the customer side, the corporate side, the demand side for renewable electricity was way behind where renewables were developed, and they've all been playing massive catch up over the years and trying to scrabble to get green supplies and green tariffs. They've seen what's happened there because their customers are saying we just won't buy from people unless you've got green electricity as your meat. They're going to see that, and they see that now. That's going to happen in terms of decarbonisation of fuel sources. So they know where it's going to end up. So I think that will take care of itself. I think from what I was listening to today, and I'm not a rail-freight expert, it seems to me that we need to work out what the solutions could be, how it could work. One of the things that's not been mentioned is the whole design at the moment around all of these production business models to get production going precludes a project from sticking any of the hydrogen produced in a pipeline. You cannot transport it by a pipeline and keep your subsidy. They're not allowed to mix it in a pipeline. You don't want to mix it with other green hydrogen in a pipeline. You lose your customer to production plants nexus, and you lose your subsidy. So I'm sitting at the back thinking, well, so the obvious thing is obviously road transport, but the other obvious thing is obviously trains. So that's something to think about. It's something that all of the pipelines, well as most of everyone else, is working out, because if you mix, for example, blue hydrogen with green hydrogen, it negates the green hydrogen. So that's the way it's all designed at the moment. So it's an imperfect world, but there's an opportunity there.
All right, people in the audience, you know, what are your takeaways today? What do you think we need to do next? And what are your questions to our panel? Okay.
Working.
Yes.
Right, where do we start? I guess we've been moving down Stuart by rail for decades and decades, haven't we? For over 100 years. Interestingly, if you read the current industry documentation on dangerous goods, there's 6 entries in which they typically call the pages of dangerous goods documentation for hydrogen. So certainly it's already legislated for in terms of rail industry documentation. We've learned today that we can manage the safety risk, but we can even take it through tunnels. We've learned that we've got the appropriate containers to transport hydrogen in either form, whether it's gaseous or liquid. We've also learned that the size of the container is probably going to be within typical ISO road transport dimensions, so up to what, 8 foot, 8'6", which makes it a going away container. The trains to transport the containers already exist this day. They're called intermodal trains. So actually, at the end of the day, we're not doing anything new here. This is just transportation of hydrogen as a dangerous good in a container on an existing intermodal train operating to any siding, terminal, depot in the UK. So I'm struggling to think of any challenges apart from one. And you know, one or two of my fellow audience here have mentioned the construction of these containers. You're going to have possibly a container where 5% of the weight of the container actually a payload. Is that about right? If we're talking about, you know, a 40-ton container or even a 30-ton container, there is 1 ton of hydrogen. Yeah. So that leads on to the main question: how do the commercials stack up?
That's the whole point. They already do it, so whether it moves on a train, it's more efficient than moving on the road. So it's an actual benefit to them.
So the commercials already stack up. So a challenge, should we just do it?
Is that right, Ross?
I can't tell you about the design of the chosen one, take the one there, but to me, the challenge is, I mean, it was really interesting for you to say all that, but it's all there. The challenge is, I would have thought, is will that hydrogen be there, will it be produced, and will there be an industry? And you can look back and you can say, well, I think one of the first speakers said, you know, when this was first discussed, hydrogen was the answer to everything a few years ago. Sanity has prevailed, and I think we're beginning to realise that actually it's not a solution for all sorts of things like domestic heating, various other things. But even if you just strip all of those out, so we're going to decarbonise industry and certain uses, and it's heavy goods vehicles or it's JCBs or whatever it's going to be. There's a market there, a decent market there already, and a growing market, and we won't be able to electrify everything. So my very novice answer, being a lawyer, but just intuitively to me, well, of course, there's going to be a need for hydrogen, and that hydrogen will also be green hydrogen, well, but there will be a market for it. The question is, how lucrative is it for you, and does that stack up with what you're having to design the kit?
So many years ago, I did a project. We were looking at moving timber by rail from the far north of Scotland. And the problem was you couldn't move it at a price that you could then sell it. It's cheaper to buy your wood from Scandinavia than to move it by train from Scotland. And we all beat ourselves up over this. And then somebody pointed out the same maths was true of the road. That even if you moved it from the far north of Scotland by road, it was still cheaper to buy it from Scandinavia, and that's presumably why IKEA boomed. So the question, I think, on the economics isn't, is it economic to move hydrogen by rail? It's economic to move hydrogen. If the market's saying it is, because of whatever subsidy that's it. Now, the only bit that matters is the delta between road and rail costs, not the fundamental cost of transport. So there is a challenge always for rail, and Andrew referred to earlier about that delta between road and rail costs. So I think a bit of the thinking that Greg and Helen, you know, we need to pick up is, are we doing things to make rail costs the same as road or less by productivity gain or whatever else we could squeeze out somehow? Don't know what the answer is. But if the core economics are great or bonkers, we're not going to fix that by rail, are we? Right.
I think, sorry, one other thing I think you've got to mention is at the moment, I think someone said we've got to stop production, 100%, we've got production business model or production of hydrogen, and the government's talking about transportation and storage business models, which are different. They're going to be regulated asset-based model for the transport of hydrogen through pipelines. They still haven't worked out the dynamic, but in actual fact, their system is not allowing mixing the pipelines, but they'll start that for a minute. So they're thinking that what they're going to do is effectively kind of regulate the use of the pipelines, the gas systems, don't pay for access, and so forth. This is all up for debate, and these are going to need to be massive investments by, as you might imagine, gas pipelines and so forth. No one's talking about rail transport or hydrogen. I suppose one of your comments was, well, what should you in this room be doing? You should be all over that transport scenarios and papers going, well, hang on a minute, this is just assuming it's going to be by pipeline. What about us? What about putting some of the costs for this so that the producers don't have to add that to their dynamics? What about some sort of subsidies to get this going, to design these things? So right, this is a solution we can provide, which doesn't mean we've got to build new pipelines left, right, and centre. We can use the existing rail network. So I would be looking at that.
Yeah, let me just take Andrew's comment on that later, and then we'll come to you.
Yeah, I was just going to make a comment. We're looking at hydrogen as a way of decarbonising. Is there an angle here that says there's a larger carbon footprint moving all this hydrogen by road compared to moving by rail? And isn't that maybe the angle you should take? You know, because if rail is more expensive, you can say, well, you're paying that premium because this is much more, you know, kind of lower carbon solution, especially if the direction is all decarbonized.
That would depend on the use of normal diesel or HVO on the road.
Yeah, or indeed hydrogen, but
you can question the source of HVO as well. So
Liam, let me come to you to do motivation.
Hi everyone, Liam Network Rail, I'm the engineering director, and
It's been great to hear and see all the data and stuff, which has been one of my key takeaways. The numbers are really good and positive to see. We've been going through a bit of a loop seeing hydrogen, and one of the things that we first found out was there was lots of, you can't do this because it's too expensive, you can't do this because it's a gas, you can't do this because it'll set on fire. All the similar things that we've heard in the room today. Last year we run a site on purely hydrogen, and we found that if you look at the transport costs alone, it was expensive. If you look at the cost of hiring manifolds and pressurisation, it was expensive for long lead times. If you look at the system over a 3-month period, and actually the total cost of using hydrogen versus diesel, it was comparable. Because you could use it in different ways, you could use it in different formats. Our biggest challenge was getting into the places that where the railway works. The urbanisation areas where we've got locations and equipment. The solution that we can only think of to get to that is using rail for it. So there's a benefit of not only moving in for logistics and for other sectors, but also for the railways. And that's something that I think is a really interesting perspective, because we've got to decarbonise the railway. We've got empty freight paths from biomass and coal previously. It just makes complete sense to me to do something different in that regard. And we have met with DESNZ, Department of Transport, etc., and said, where is the railway in this? Why does the white paper for hydrogen not include the fact that we already link these ports and the locations of the with the railway? It seems absolutely nonsensical. And I asked one of the panel chairs for one of the hydrogen groups, and our view was, well, because no one sitting around the table is from the railway. We have highways people here, we have transport people here, but we don't have railway people opening our eyes to these things. And that was only a couple of months ago. So I think there's an opportunity for this room to have a much wider voice. My question, and sitting here and listening to this, and even the discussions that are taking place in the room, the answer to all the problems are in this room, I would say, the majority that we've come up with. What I can't get to understand is, why can't we seem to mobilise to support that problem? And is it a function of time, or is it a function of incentivisation? Because a day of us spent talking and going through this, I suspect there are some ready-made solutions out there. And we found when we did the trial of network rail that the solutions were there, we just didn't know they existed or how to access them. So, to summarise, is there something missing in the discussion, which is more around broader incentivisation rather than just political motivation to do targeted activity?
So certainly from my point of view, you know, I haven't got to deadness yet, because I suppose we spend 95% of my time looking at rail reform, frankly. But you're right, we ought to be, and now is, you know, one of the reasons why Greg and I tried to get today together was because we realised we were missing that beat. I think as well, and we haven't got DFT colleagues here either, but they don't know what's going on either, bluntly, within government. So I think sometimes we assume that they're looking after our interests, and I don't think that they are. So Greg, we should pick up an action with colleagues to make sure we're looking at all those documents. I think the other thing, Greg, I'll come to you on, is the trial that Leaving and Co have done. Is that something that we can promote?
Don't see why not. Well, promoting it within network rail would be a good start, because it's not something that massively cited on. So I think that's a, you know, ultimately network rail is a vast organisation, so you don't, it's what the challenge is, what's going on. But absolutely, because it kind of comes back whether you're doing a physical trial around or anything else. It's kind of by the fire, if it's to do with rail and it shows what could be possible. Why not? You know.
Andy.
Right.
Mike.
I'm Stuart.
You hear me okay?
Yeah.
Andy Parker from Direct Rail Services. For those of you who don't know, we move nuclear fuels on trains every day. Yeah. I dread to think what you'd be saying if we're talking about nuclear fuels. We're talking about hydrogen. First and foremost, on behalf of Direct Rail Services, I'll put our hat in the ring for the trial. Yeah, we'd be more than happy to talk to you guys and see what we can do. And I'm very much along with Carl Watson. Come on, guys, it's a box. At the end of the day, it's a box. Yeah, we'll put boxes on trains every put hundreds of boxes on trains every day. When you talk about the economics, the difference that I can see is that you economically works on road at the moment, but that's because you're talking about one move. A train's 30 times more than a truck, so you need 30 boxes going from A to B. That's the bit that I don't understand yet. Yeah, where is 30 loads going from, and where's it going to? Or is it ever going to? That's the big question.
Yeah, I agree, and I think, you know, we've sort of half gone there today, it's a bit uncertain, but actually the bit that I've taken from today is that if we've got 1 box of hydrogen and 29 boxes of imported Chinese crap, it doesn't really, sorry, tax, it doesn't really matter, does it? You know, actually, that there's some opportunities that I've not thought about until this morning of mixed trains, and that I think could help us on that transition potentially, yeah.
Is a train of 30 wagons a moving coma site in some way? Sorry, is a train of 30 wagons a moving coma site in its own right?
I think it's common if it's in transit. It's in transit.
I was hoping this was going to be on to this sort of final statement, and I don't even know in my own head whether it makes sense or not, but railway, to my mind, needs weight and distance in order to be economic against road. What we're describing here in terms of one of the issues with hydrogen is that it has an awful lot of tear condition going with it in both ways. Essentially, the wagon runs full in both directions from a weight perspective. So just in terms of that ratio of weight and distance, maybe we should be thinking about hydrogen in order to be economic against the road. Only it needs half the distance that a typical goods would, because actually you're running the same to weight in both directions.
Right, look, unless there's any more questions, let me try and do a bit of summing up and where I think we might get to. Right, so firstly, I think it's been brilliant. You know, I've learned a huge amount, and I've been asking people about hydrogen for 2 years now, so I smugly thought I could whack my way a little bit, but it's apparent that I can't. So thank you to everybody for all your input today. It's been amazing. I think we've got some things we could immediately start to do. So Greg, you're already kicking the tires of colleagues on dangerous goods. Helen's given us some links on the work that's already been done at RSSB. We need to get that out and air it and put it all together in one place, which is probably where you're already going. We've got colleagues here who are moving this stuff already around the UK on road in demountable units. So if people haven't been talking to XP over the coffee break, you need to, because we've probably got some things that we could do quickly. And if we're doing them on an existing container train, dare I say it, they might get MSRS, notion of revenue support, because it's a container, so that might be one to think about. Then there's an action about getting to DESNES, and I expect Andrew and Ross, we might be asking for your suggestions about how best to do that, or at least some links to some documents for how we can start that. And we have pushed DFT, but I'll be honest, I haven't pushed them very hard, so I will try and push them harder to make sure that they're playing in those conversations as well, because I think they need to be. So we'll take an industry action on that. We heard about 2 different people looking for trial partners, Robert and Helen. So I think, please do follow both of those up. You can get the slides with all the contact details, but I think if we can get some stuff moving, then brilliant. Let's not forget, we did talk a bit about using hydrogen in locos and the OH shunter demonstrator. So that's another thing that people might want to go and take away and pick up. Leven and Greg are going to talk about the trials that I've already done that nobody knew about, and see if we can help promote those and see whether there are some opportunities for more of that. Because the more we can do to prove the point that the railways are using and moving hydrogen, the easier it will be to make the case, even if those things are quite small. Right, what have I missed?
Don't forget the magic sponge.
Magic sponge. Does that sound like a plan?
Yeah.
Good. Right, I'm gonna go down my panel for some closing remarks. Alan.
I'm with Carol, I think the challenge isn't really a challenge, I think we did this. Just for the way of doing it.
As we have been, and as I and we always will be, there to help in any way we can, so please reach out if you think you can do so.
If you look at the current hydrogen projects that are out there, there are the big, huge blue hydrogen carbon capture clusters, which will have their own pipelines servicing dedicated plant, or they are very small, early stage green hydrogen projects built to service the next door sites, provide them with pipes supplying hydrogen, because that's the only option they've got because of transport not being sold and not being incentivized. We know that green hydrogen is going to take off. We know that there will be more of it. Once those early stage projects are approved, which will take a while, then that economy is established. Park the green clusters because they will service themselves, but there's going to be a need for transport to get the hydrogen produced to wherever it's going. So there's got to be an opportunity.
I think from my perspective, it's I'm the for today, and I'm involved in it quite a bit with APP. It has raised more questions than we've got the answers. Well, in this room, the answers are in this room, so it's just a matter of just mapping them out, working your way through them, and coming up with solutions, and then making it happen. So I think collectively, if we can come up with an action plan to make that work, and get there, those trials.
I should have said as well, let's not be sat here in a year having exactly the same conversations. That's absolutely demonstrable progress.
Right, well, we'll take an action to check in the year's time, bro, see what you've done. No, seriously. Look, all right. I think that it's been a fabulous day. I wasn't really sure how this was going to work. It's worked brilliantly. Can I just say a huge thank you, please, to all our speakers today. Thoughtful, knowledgeable, covered a huge range. Didn't get faced by any questions. So brilliant. Thank you all. A huge thank you as well to Stuart and particularly to Jenny here at BCRRE for hosting us today, providing the tech support, sorting out the mics. Great venue, and I know those of you who are going to go and have a look round in a little while will be really pleased with that. And thank you to Yvonne who's put in huge amounts of work getting this event together from our end and ordering the sandwiches, which were nicer than I'd expected, frankly. So I thought we'd order the cheap ones, but you know, there we go. Thank you all for your participation and questions. It's great to see a room full. We will come back with the notes just of the key actions that we've got. If you want the slides, later on there. In fact, with the note, what we'll do is we'll just put it out on our members update, and then you can see what's there. But we've got those key actions that we'll grab. Ask Yvonne if you want to copy the slides because we have to send them out by visitor.
Yeah, well, I have to send them by WeTransfer anyway. So what I might do, I'd just like send everybody the link, and if you don't download it, you know, it probably makes it easier than me getting all the emails. The other thing is, can I have your badges, please, before you leave? And the people who want to do the tour, if we meet in the front here in 5 minutes or so. Yeah, right.
Perfect. Thank you all very much. Enjoy the rest of your day.